Are you ready to unlock the hidden potential of Devops tools and embark on a thrilling journey into the world of seamless software development and deployment? Prepare yourself for an extraordinary adventure with Devops Mastery, the ultimate key to revolutionize your business and shape the future like never before. Imagine a world where software development is a breeze, where teams collaborate effortlessly and innovation flows like a mighty river. Welcome to the realm of DevOps, where productivity soars and time to market shrinks, giving you a competitive edge like no other. But that's not all. Brace yourself for a mind-blowing revelation. DevOps has emerged as the undisputed champion of the software development landscape. With over 80% of organizations adopting DevOps practices, it has become the driving force behind the success of tech giants and startups alike. The demand for skilled DevOps professionals is skyrocketing, and the opportunity for you to thrive is boundless. Now let's dive into the numbers that hold the key to your future triumphs, the ones that will ignite your career like a supernova. DevOps professionals are commanding top-tier salaries, with average annual earnings ranging from $90,000 to $140,000. As you master the art of DevOps, you will unlock even more thrilling opportunities in this rapidly evolving field. If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course. Immerse yourself in awe-inspiring success stories from our satisfied learners who have harnessed the transformative power of DevOps to achieve the extraordinary. The future of software development resides in DevOps, and it's eagerly waiting your arrival. Are you ready to seize it and soar to unimaginable heights?
Hey there, my name is Manuel Canelon.
And I'm Rafael Canelon. We're actually brothers and we live here in Alberta, Canada.
We do a lot of things together. And this time, we decided to take a course in DevOps from Simplilearn.
The course proved to be very beneficial for both our careers.
Yeah, I got a promotion after the course.
And I got hired with a new company.
I'm actually a mechanical engineering graduate, and I've been working at my company for the last 4 years. In 2020, I came to know that my company was starting the hiring process for a DevOps infrastructure team. At the time, I was working as an implementation specialist, and my colleagues recommended I take a course in DevOps if I wanted to be part of the team. So I started doing my research, and then he came to me saying that he was also looking for a DevOps course.
Yeah, funny enough, I actually found the course through Instagram. But my situation was slightly different. I had been working as a geomatics field technician for about 4 years, but I wanted to change my career into something that involved more programming and automation. So when I came across with this course, I said, you know what, let's take it.
And Caltech's name was definitely a deciding factor. In July 2021, we got our certifications, and I immediately posted that on my LinkedIn profile.
Coincidentally, in November of that same year, we got the good news, and I got hired as a GIS developer, which has allowed me to do way more programming, which is what I wanted to do.
Around that time, I got promoted to the DevOps infrastructure team and saw a 21% salary hike. The overall course was awesome, but the part that I enjoyed the most was the Docker certification training.
You know what? I also really enjoyed the Docker certification training. I think that we're brothers after all.
Yeah, the experience was amazing, and being able to study together was definitely very nice.
Yeah, it brought us back to those good old days when we were going to school together.
We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as MAVEN and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit, is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments, and so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted. What we're going to do is we're going to break up the tools into 8 different categories. Now we're going to go through the planning and code-based tools, the building tools, the testing tools, the all-important integration tool, the deployment, operation, and then finally monitoring tools. Something we should also add is that all of these tools are open source. This means that you can get up and running with your DevOps environment immediately without having to worry about licensing costs. So let's jump into the very first tool, which is Git. So Git is a distributed version control tool that allows development teams to be able to share code amongst each other in a way that allows the creation of small to extremely large applications to be created effortlessly. If we look at the architecture of Git and the way that it works, that there are 4 key areas. We have the working directory, the staging area, local repository, and then remote repository. So your working directory is where you actually create all the files that you'll be working on in your application. The staging is the area that you get ready to commit those files to your local repository for version control. And once you actually have then put them into your local repository, then you want to be able to push those files using a push command out to a remote repository such as GitHub or GitLab. In addition, if you have a distributed team, you can then also pull down the latest files. So as a team, you can always be working on all the files all the time and then go through the whole process again by working on your local files. You can do this whole process really quickly and easily. Git is actually a free tool that you can download and run through command line off your computer. Finally, you want to be able to merge files that you may be working on, say for instance, a different branch, which is a new feature. You want to be able to merge those files back into the master directory, the master branch that's running on Git itself. So some of the things to point out with Git, what makes it really useful is that it's absolutely brilliant at being able to track changes in your source code. This is something that source code tools really kind of should be able to do, but Git is exceptionally good at this. Having large teams working at different phases within the project and working on different branches within the project is really easy to do, and the collaboration tools within Git make it so that your teams can work effortlessly with each other. Inherently, you are creating backups of all your code, which is fantastic. And probably most important part is that the environment itself is a non-linear environment. This means that you don't have to work through specific gates to be able to reach feature, to actually get a feature ready for delivery. You can actually work in a non-linear fashion. So who's using Git? Well, as you can imagine, all of the big technology companies are using Git, including Netflix, Lyft, and Intel, plus many, many other companies. So let's get on to our next tool, which is MAVEN. And the focus on MAVEN is to automate the build process of code that's being checked into a repository, such as a Git repository. So if we have a look at the architecture here, MAVEN itself actually executes what are called POM files, and those POM files actually then look for specific dependencies that will then go against a repository to be able to build out the project. You can actually extend the POM files with plugins, and you can actually then create a specific build profile for your environments, which is actually fantastic because you can really fine-tune the profile. And again, all of this is scripted, and this is something that is common with all the tools that you'll be using in a true DevOps environment, is that you can script all of them, which means that you can automate the processes that are in your DevOps environment and really accelerate the ability to be able to build consistent, high-quality software. Final step for a MAVEN environment is to actually build all the software into in our build server. So a couple of things that are important to notice with MAVEN. One of the things that you'll see that's key with all of the tools that we have here, really easy to use. MAVEN itself It's got a pretty simple setup. It's highly available, which means that your teams can rely on the solution being ready for your environment, and you can actually get to it and use it very easily and consistently. You can have multiple builds happening at the same time, which is really important, particularly if you have branched software and you want to be able to test the branches. And the other thing as well is that it's open source, so you have instant access to new features without any additional configuration. So it really helps your teams to get the new code and implement new features within the environment itself, so you're always working on the latest and greatest. As you can imagine, DevOps shops such as Zillow and Zenz and JP Morgan and Chase are already using MAVEN, and you'll see that many DevOps shops are also using MAVEN for their build software. Testing with Selenium is very important, and being able to automate that environment is critical so you can actually guarantee that your code will work. And Selenium itself is designed for testing and automating web applications. It's really good in that environment. If we look at the architecture, the way that it works is that you actually have a client library that goes against the code you're writing, whether that's C#, Python, Java, JavaScript, and then there are specific drivers that go against the web browsers to actually test out the code that you have created so that you can actually see whether it works in the appropriate web browsers. And all of the popular web browsers are supported with Selenium. Selenium is an open source solution. It does allow you to write scripts in multiple different languages, which is a real big bonus. You can as well run parallel test execution, so this balances very well with MAVEN. And as with other tools that we have, it's really easy to use. And Selenium is being used by Google, HubSpot, and Salesforce, as well as many other companies. So let's talk about the really important part, which is integrating all of this. And Jenkins really is the de facto tool in this space. And so the role of Jenkins is to be able to manage and allow for that continuous integration that you need to make DevOps successful. So allowing the development team, to integrate effectively with the ops, the operations team, and do that through testing and management of the code that has been created. So if we look at the architecture here, we have our remote source code repository. It's going to be waiting for a Jenkins pull to be able to create a commit, and then that Jenkins serve master will then push out and distribute the work to multiple slaves so that you can actually have the actual code being pushed around your environment. So Jenkins is really easy to use. It's very mature. It's been around for many years. There are a significant number of plugins that allow for the Jenkins environment to be scaled very effectively, and it is portable across multiple platforms. In fact, most of the leading operating systems will support Jenkins. And as you can imagine, Jenkins is being used by companies such as LinkedIn and Microsoft, eBay, Dell, and Cloudera. So let's talk about the other side of DevOps and talk about some of the operations tool. And we'll start off with Docker. So the role of Docker is to make it easy for people to be able to simulate full environments quickly and easily on their desktop for building and testing, but at the same time make that real easy to be able to port those environments across multiple areas. So let me talk a little bit about how that would work. So with the Docker engine, you have a Docker client locally that allows you to emulate the whole Docker environment without having to have the overhead that you would typically have if you're doing virtualization or dedicated servers running specific dedicated operating systems. Because you are scripting the entire environment, Docker is a very scalable and repeatable environment for being able to take across the entire cloud network. So some of the features that are really important for Docker, it's incredibly portable across multiple platforms. The Docker team have done a fantastic job on portability. It does run in isolation. So what this means is that you can actually have multiple Docker environments running on a server concurrently, and they will not interrupt each other. They actually fully isolated sandboxed environments. So the other part to Docker is because it is stripped of needless operating system and host environment APIs and services, the actual startup and boot time for Docker is really very fast, which in turn makes this very scalable and efficient to run. And you can actually reuse volumes very easily. So who's using Docker? Just about everybody. Spotify, Uber, PayPal, BBC. Really, Docker is used by a lot of people. Just a side note, probably something that would complement Docker very well is Kubernetes. And and Kubernetes is becoming a very popular alternative to Docker. And so, really get to know both of those tools. So let's talk about some of the operation and management tools that you have for your environment. And the three big ones here are Chef, Ansible, and Puppet. And we'll start with Ansible. And Ansible is a configuration software package. And unlike the other two products here, unlike Chef and Puppet, Ansible doesn't actually require a client to run on the host server where you're pushing out a configuration. You can actually have a defined operation configuration, so like a web server configuration or a database configuration or an IoT cloud configuration. You can actually have that running effectively from a script that is written on a client machine and then on your local machine, and then you can push that script that you've created out to your remote servers and have everything work as you'd expect quickly on your remote servers. Just some of the key features of Ansible. It's incredibly lightweight. One of the things that's really important with Ansible is that it's actually very easy to use. There is, unlike the other two tools we'll be covering, unlike Puppet and Chef, Ansible actually has a full GUI that you can use to actually interact and build out solutions. So there is a visual interface that you can actually go in, so you're not just working completely in command line. Companies that are using Ansible include Twitter, EA Sports, Cisco, and NASA, as well as Verizon. So complementing Ansible, but probably a little bit more popular right now, are Chef and Puppet, and we'll cover Chef first. Both Chef and Puppet are somewhat similar in configuration, and both of them rely on having a client-server relationship with their architecture. The way that Chef works is that Chef actually creates recipes, and each recipe is a server configuration setup. And what you actually do is you create individual recipes, and then for your entire network you create what's called a cookbook, and that cookbook actually can be used to control the setup of your entire network. And this works really well for being able to create consistent and highly scalable environments. The things that are great with Chef is that it's actually a very flexible configuration, and you can actually do an awful lot with it. It has really good security features, which are very appealing to, particularly if you have a DevSecOps environment where the security team are integrated with your DevOps environment, and that's something that's becoming more and more popular. Chef itself is actually pretty easy to use. It is a command line tool, but it is actually fairly easy to use, and the actual scripting of the recipes is something that you can do even if you don't have much scripting experience. It's something, there are so many recipes out and available, you can actually use many of the templates that have already been written and just either copy them or modify them to your environment. As you'd expect, a lot of the companies using Chef are the big technology companies such as Facebook and IBM. Microsoft in particular has really invested heavily in Chef. In fact, you'll find that Chef is probably the most popular management tool used within the Azure environment. So a complementary product to Chef is Puppet, and if we look at Puppet, as you can imagine, it's again another open source configuration tool. The structure, as you can see, is actually very similar in concept to Chef, in which you have a local server that actually has all the configuration environments, the templates and the files and the manifests, and it will actually then communicate with all of your entire environments, such as, and with Puppet they refer to them as nodes, and within your node you have multiple servers. But it's similar in concept to Chef in many ways, in that it's just another way of being able to control your environment. Both are really great tools. In fact, really all three of them, Ansible, Chef, and Puppet, are great tools. What you have to do as a DevOps team is really just decide which tool is the one that's appropriate for your environment. So some things that are great with Puppet: it's multi-platform compatible, it's very scalable, and it allows you to push out changes to your environment really fast. And who are using Puppet? You've got Red Hat, HP, Google. Leading DevOps teams are using Puppet today. So let's get into the two tools that we have that actually monitor our operations environment, Splunk and Nagios. So Splunk is, as you expect, is a monitoring tool, and its goal is for actually monitoring the operations of all the environments that you have, make sure that they're working correctly. And it does this by going through and reviewing your entire environment and writing the operational information to disk, and then searching that environment to make sure everything works correctly. It does a lot of analysis in real time. It is a very easy to set up and use tool for testing for analysis. and to then be able to then troubleshoot any failures that may come up. The thing that's great about Splunk is that you can actually put it in a distributed environment so that it's no single point of failure, which makes it itself inherently very, very scalable. So Cisco, Facebook, Domino's Pizza, Dubai airports are all customers that are using Splunk today in their DevOps environments. So finally, let's jump into our final monitoring tool, which is Nagios. And very similar to Splunk is Nagios. Probably the big difference is that it's client-server setup, but really, again, it's all about being able to monitor and check the status of your entire environment and your network and your servers in real time, and give you the appropriate visualizations, whether it's on your laptop or whether it's an alert that's sent out to your phone, and so you're aware in real time how your network is performing and can then check and adjust to actually making changes. And the bottom line in this kind of architecture with Splunk and Nagios is that it allows you as the operations lead to be able to be ahead of any perceived impact. So say for instance you are putting in specific check marks for your environment, you can actually have alerts being sent out to your team when certain thresholds are met, and so that means that you are aware of problems with your environment before your customer is. There's nothing worse than somebody emailing and saying, hey, your website doesn't work, or like a page is down, or it's slow, or something like this. With Nagios and Splunk, these are tools that really address those kind of problems so that you stay ahead of the curve. So some of the things that are really good with Nagios is Nagios itself is very, very comprehensive. You can do an awful lot with it, and it allows you to be able to get to the root of monitoring and analyzing your problems within your operations and network environment very quickly. It has a very modular architecture, which also then makes it extremely highly available, because the system itself is not reliant on just a single large application. Actually, the modular architecture allows it to be scalable and very easy to manage across the entire environment. Companies using Nagios include Uber and Hike and Webedia. Again, these are all technology companies, but there's no reason why you shouldn't be using them as well.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
What are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code and that your code will be stored in a centralized location. However, the challenge you run into is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git clients to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public and shareable. It is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are thousands, 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way, way, way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects where, particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made, so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here. And then here we have a separate parallel branch, which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch. And we want to do a Git rebase. So we're at stage C, And what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's being done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you can then merge that into the main branch. A git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory so I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the readme file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into readme file, and I can change this. So we can go hello git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the readme text. So to do that, we'll use the diff command for git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world, and then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/Simplilearn-GitHub, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/simplilearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project because I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, if I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in, and we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature, and then we can then paste in the URL of the new directory that has the forked work in it. And now at this point we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators, so we can actually then go over to GitHub and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators, and here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name or by email address or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. Call it test, and we're going to move into the test folder, and we will initialize that folder, and we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2, and now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit, and it's gone ahead and added those files, and so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test underscore branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test underscore branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test underscore branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test underscore branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modified. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a, and we're going to commit those files. Git commit -a-m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. And we can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list And there we have all of our files.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Start by downloading and installing Git on our system. We'll then have a look at the Git bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository. And finally, we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows. And I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system and it's downloading. So this will take a while. So Git is finally downloaded. Now we need to install this on our system. Click here, run. So go to next. We don't have to change this path. Just click on in quick launch and on desktop. Next, next, again next. Nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes. We just want to launch the Git bash. So let's just tick that and then click on finish. And your Git bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command. And as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config -- help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello Simplilearn. Save this file and go back to your bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared, it's visible, but nothing is committed yet. So this means that we have not made any change to our file through the Git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as you can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile and My username is Simplilearn-GitHub. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, Simplilearn-GitHub, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo. If you have any queries regarding this, please post them in the comment section below and we'll get back to you as soon as possible.
I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git bash. But what does it take for you to share this repository with another user who has also got Git bash installed on his system? This is where you would need something called as a Git server. So for user one or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free. Some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very, very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition, which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I will register myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with, say, user2, the first thing that I got to do is have an access to a Git server where both user1 and user2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user2 or the other developer who wishes to collaborate with me on this repository can use his credentials. As long as he's registered properly on the Git server, he can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. Alright, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use Git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. Alright, so looks good. I don't want to see the release notes. I'll say launch Git bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. All right, a lot of Git help commands. Everything looks good. So I ended up installing the Git bash. I can go ahead with all other commands. Now that I have Git bash installed on my system, let me open up a Git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and this the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete that in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master, and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. This was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file. Write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I'll log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name, so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that, because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the Create Repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file, which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I will click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. Alright, so for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with a README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. Alright, I say create a repository. So a random README file with some content in it gets created and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. Alright, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, Looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial when I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 files, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change, you're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your Git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. Alright, so this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So, in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead. From C5, I see another commit. But what was there as a part of this commit? Actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2 and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation, both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch, and once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. Alright, this is my folder here. Alright, I navigate into this folder and let me create a repository here. I initialize a repository, and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. Alright. So if at all I do a git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only one commit, and there are two files here. You can see those two files that is here. Alright, so at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, this is exactly two files the way it was earlier, because I've created a branch from my base branch, which is the master branch, and when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. Alright, So let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn, Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. Go here and say new repository. Alright, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. Alright, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server. And let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. Alright, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. Alright, now it created a branch out here. Let me do a refresh of this. Alright, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in two branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these two branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git checkout, the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. This would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of prime DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Now we will be talking about that how exactly we can make use of MAVEN here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use MAVEN here. Now MAVEN is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily to daily activities. Right now, MAVEN also helps us in getting the specific jar files for each and every project. So if you are you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your MAVEN there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it, the dependencies of each and every third-party binaries on the mvenrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvenrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right, so now what exactly is a MAVEN all about? So let's see on that part. So MAVEN is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish, and deploy several projects at once. MAVEN is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the MAVEN here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. right? Now Maven is a kind of a POM based project, so it also known as an project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now what exactly is a Maven repository all about? So Maven repository is something which is a kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three types of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository and then it will be utilized. So if you feel that the dependency is something which is not there in the local, it will be first downloaded from the remote repository and then it will be utilized or will be referenced onto the local machine there. And central repository refers to the Maven community repository there, where you will be able to see each and every dependency present on that repository. So Maven downloads the repositories from here in the local repository whenever they're needed or whenever required. All these dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right now, what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning. Versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which search for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step. Otherwise it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right now, second thing is the dependencies and repositories. So dependencies usually refers to the jar files, so the Java libraries which we need into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download or we have to actually refer, and once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important, because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executable will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement, and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default, so it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site, so it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now, what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. Right, and Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package, and depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that, the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like MAVEN. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called MAVEN archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So MAVEN archetype generate. Now once we run that, so what will happen that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us a particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com.Simplilearn. So that's the value which I'm providing here. Artifact ID I can make it like sample project or something like that I can do. So that will be the artifact ID which is there. So version I am keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that, the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement, and this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if you run like MAVEN clean install, so it will be considered as a particular MAVEN project. A pom.xml file is already there present in the local directory. So according to that, the execution of the steps will be performed, and according to that you will be able to get some desired values here. So ultimately in the target directory you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending on your understanding, you can keep on adding or you can keep on modifying the dependencies, and that's how you can get the final result there. So that's it for this demo in which we have find out that how exactly we can go for a particular project preparation with the help of MAVEN executable. So that's it for this demo. Thanks. Right. So that was the demo in which we saw that how exactly we can go for the MAVEN, and we can execute some build process related to MAVEN there. So this is the Mac system which we have here. Now in this one, what we are going to do is that we are going to open the terminal. So we are going to open a terminal here. So this is my terminal. So usually in Mac you don't require any other mechanism, so the inbuilt terminal is more than sufficient for doing this stuff because it's similar to a Linux based platform here. So I'm going to run the command here. So first of all, I'll just double check that if my brew executable is working fine. So I'll just run the brew help command to see that if my brew is working fine as such over here in this one. Now I have the command called brew install. So that is a command which we need to use. Now in this one we have to actually give the specific package which we want to install. So we will say like brew install MAVEN. So it will download the specific executables on the system. From the website it will download the MAVEN executables. So it will take some time, but ultimately it's trying to download it under the particular tar file. So you can see here that it's downloading 3.6.3 tar file over here. So I can see that the installation is done. So the 3.6.3 version should be installed over here. So when I do like MAVEN MAVEN under hyphen version over here, so you can see that the 3.6.3 version is deployed as such over here. Now this is something which is done with a purely command over here called brew, which really helps us to do any kind of package installations. Not only MAVEN, other packages also can be installed pretty much with the help of this executable. Now in order to see the manual stuff, what we really need to do is that we need to actually clean this specific installation, so that I will be able to show you the manual installation also over here. So what I'm going to do is that I'm going to run the command called brew uninstall MAVEN, so that the MAVEN should be removed from your system. So we are just trying to remove the MAVEN from here, and you can see that the MAVEN executable is not working as such over here. So which means that the MAVEN is uninstalled in this case. But why I have uninstalled here? So that I should be able to go ahead and download some custom MAVEN over here in this one. So I have opened the browser here. So I'll go for the MAVEN executable. So we'll go for MAVEN download, so that we should be able to download a specific the executable here. So I'm going for this directory. So here 3.6.3 version same is available here. So I'm going to download the bin.tar.gz, which was the file we have. So this is also a kind of a Linux platform, right? So That's the reason why here the tar file should work perfectly fine. So here I'm going to the OPT directory where we can have all the optionals related packages. So if it is not there, so I can create a directory called /opt. So I can log in with root. So if you don't have the root access, so you can go for the applications. In the applications, you can actually create a directory called MAVEN. So here I can go for MAVEN. Yeah. So here we will be downloading the var file here. So the tar.gunzip file we are downloading over here. So I'll give the path here. So once the var file or wget command I am using to do the installation, but sometimes the wget is not available. So I can go for the brew install wget also. If that package is available on brew, the installation will be done. So we'll try to do the installation using wget so that we will be able to get a tar file generated or downloaded. There are other ways also. You can download it from the browser also. Yeah, you can go to the browser and here you can actually click and download it, and then you can transfer it locally to this specific directory also. So both the possibilities are there, but I'm just trying to download the wget command so that it will be easy for me to do the setup and to do the download over here. So I'm going to run the same command again. So it will download the tar file. So this is the tar file which is available over here. So I'm going to extract it over here. So once the extraction is done, so I'm going to rename it like to Apache Maven, so that I should not have any kind of versioning or these kind of parameters over here. And the Apache dot Maven hyphen this tar file I'm trying to remove as such over here. So this is what I have got as an end result over here. Now this is the current directory in which I have these applications and these setups going forward over here. So if I run the mvn hyphen version command, so that will not be giving me any kind of output over here, because still I have extracted the tar file, but that is not, the activity is not complete. I have to exactly set up some environment variables so that I should be able to run this mvn command. So what I really need to do over here is that we have to export certain variables. Application / maven Apache Maven. So this is the home directory which I'm trying to configure over here. And then next thing is that path variable. So I'm going to have, we are going to coordinate the path variable with the folder. So I'm going to have the folder structure here. So the bin directory we have to provide. So I'm going to copy here and paste, and then I'm concatenate it with the bin here. So now my environment variables are established. So my mvn hyphen version command, as you can see here, is that it's being picked up over here, but it's saying that the particular Java runtime is not available. So I can go for Java brew install Java. So that should be enough there to install a Java package there. So you can see that it says that it's already installed, so and up to date. So that's the reason why it's not able to do the installation. So I'm going to reinstall OpenJDK. Because what happens that when we do the installation, some environment variables related to Java should be formatted or should be extracted over here, right? So as you can see that here it's saying that if you want to really use the executable of Java, you have to concatenate the path like this. So let's run that, and then we can see that the particular executable of Java will also be find out over here. So Java hyphen version showing that yes, it's available there. And now my command should be able to show me that yes, it's working fine. The GDK was already installed, but the problem with that is that since it's installed into a particular location, so you have to actually override your path value so that you should be able to see in that directory and find out the Java executable. So that I have got by doing the deinstallation. I got the command over there in the output saying that this is the installation which is done, and now you just have to extract, or you have to just put that path directory into the specified specified path variable, and that's how you got the Maven and Java both command lines working over here. So this is how you will be doing the Maven installations all together, how the overall installation of Maven and the JDK really works on Mac operating system. Right. So before even going for Maven, we have to install the JDK onto our Windows machine so that we can proceed with Maven, because Maven requires the JDK installations to be there. Now there are two ways of JDK installation. Either you go for the exe file, or you extract the binaries of JDK to a directory and then set up the java_home path for that. But if you are using the executable, that will perform the path configurations for you also. So in that case, you don't have to reconfigure it again and again. So that's what we are going to see here. So first of all, we will try to do the installation of JDK. So for that, we'll go to the website of JDK, and then we have to click on this one to access the Maven installations part here. So that's what we are going to do. So let's proceed, and let's open the Chrome and try to go through these two URLs so that we can do the installations one by one. So here I have to just search for JDK 8 download. So it will show me the URL for oracle.com. So here you will get the JDK for the different platforms, for different operating systems. Now here what you can see here, that you have the configurations in which you have the JDK installation. So we have to So here I'll go for the Windows 64 version, because that is something I will be using to do the installation. So this is the complete executable link. So here you can download. So we are downloading the SDK U251. So just search for Windows 64. Yeah, this is the one. So let me click on this one. Let me quickly log into the web page. So once the login is done, you will be able to see that it's trying to download the exe file. So that was for the JDK, for the Java. Now for the Maven, I'm going to go for the Maven download over here. So in this one, the Maven repo link is there. maven.apache.org is the link for this one. Now here we have the different options. You can see here that the binary zip archive is there, then source zip archive is there. So depending on the installation which you want to perform, you should be able to download that file and it works there. So let's first install the JDK portion, and then we'll go with this one. So we'll click on this one also anyways, because it's something we have to anyways do it. So we'll click on this so that this Maven is also getting started downloading over here. So once both of them are downloaded, we will proceed further with the setup. So let's wait for another 1 minute to do this one. So the Apache Maven is kind of downloaded over here. So we wait for the JDK download also over here. So next 5-10 seconds only left out. So first JDK will be there, and then Maven installation configurations will be there. So for Maven, we just have to extract into a directory and give the MVN home path into the properties, into the variables, so that it can pick it up over there. Okay, so we have to extract the zip file for Maven, give the path, and then we will check with the Maven command whether it's working fine or not. So let's try to install the executable. So we'll open the directory where the executables are there. So first of all, we'll install the JDK. So we'll double click the installer for JDK. It's of around 200 MB. So the complete JDK will be installed. So we have to just go for next. Now when you go with the installer, so usually the Java home paths and all that stuff is already configured. So you don't really have to change the passwords or Java home, any kind of variable you have to put it up. All those things will be automatically cleaned up. So it's running the installation. Close. So then we have to extract the Maven. So we have to extract this directory, because here the Maven complete executables and libraries are there. So we just have to extract it and place into a directory so that we can further on use it and access the path. So once the access is done, yep, so this is done there. So I can rename it to like Maven. So I can rename it like to as Maven, and I can cut it down and put it into the C drive here. Now this is the Maven home path which is going to be there, right? So all I have to do is that I have to close this one and this one and this one and this. So what we have to do is that we have to really go to the system properties so that we can extract it. So I'm going to open the system properties over here. properties. Now here the advanced system settings. Now in this one we will be setting up the paths, so environment variable will go. Now here if you scroll down, you will see all the different paths which is available there as such over here. Now if we want to see that if the Java is fine or we require for JDK also, so all we have to do is that we have to open the CMD prompt. Window R we are providing, so using the window R I'm opening the run window where I can say like CMD. Now in this CMD I'm going to say like Java -version, so Java is there, so which means that we don't have any problem as such. Now I'll just go here and set up a new one called MVN_home. So here the same path, so you can browse for directory also, but I am using the MVN home over here in this one. Now I have just added that, and in the path variable in the last we have to actually add the bin directory also, so that whenever we run the MVN command, so that should also be resolved. So MVN_home is not the only variable which you will be configuring. In fact, you will be configuring the path variable also, that you can go ahead and put up a new directory entry for the CMD here. So CMD till the CMD directory, you will go there, and whatever the executable is there, you should be able to resolve that. So for that, again you have to open the window R, CMD prompt, Java-version, and then you can run MVN-version here. When you run the MVN-version, it will let you know that which particular Java runtime you are using, 1.8.0_251. That's the same one which we have configured. And it also let us know that where exactly the executable is there, and we can now proceed further with the execution of the Maven build. So you just have to check out your source code or go to that directory where source code is there, and you can run the MVN clean install. So that will ultimately go for the build process. So this is the way that how we can do the installation of Maven on the Windows platform. Now since this is done, now we will go ahead with the second installation, where we are going to do the installation of Maven and JDK onto the Ubuntu machine. So for that we will log into the particular cloud lab of Simplilearn LMS. So let's log into the LMS here. So now we are going to do the installation of JDK and Maven on the Ubuntu virtual machine here. So for that we will log into the LMS. So let's log into that. So this is the LMS over here. Here I have already started the lab here. So all I have to do is that I have to just click on this link here. So it will open the lab into a new tab. It's a GUI mode of Ubuntu server, so which we will be using to configure it. So here first of all I can open the Chrome browser also. So let me open the browser here so that I can download the Maven executables as such over here. So JDK we can do it using the package installation. So using the apt executable we will be doing the installation. So I have to just open the terminal here. So once the terminal is opened, you have to log in through the root ID. Now why we require root ID? So that we should be able to do the package installations and other configurations. So that requires root access. Now once that is done, you have to run the particular app update command. Next you have to install the installer. So the Oracle installer we have to install. Now once the setup is done, so let's install the latest package over here for Oracle-Java 14-installation. So this will install the JDK 14 over here. So for that configurations. Now at the same time we'll go for Maven download also. So here we'll go for download Maven. So this is the tar file for executable. So I'm going to copy this URL here, and over here we'll say yes. So now the Java should be configured and should be set up over here in this one. So what we really need to do is that we need to run the Java command to see that if the installation is done properly or not. So let's open the terminal again, another terminal, so that I can perform the steps related to Maven. So I have got the URL, so I'm going to the OPT directory, which is always an optional directory where we can do the setup and all those configurations. So I'm going to run the wget command and then the URL which I have downloaded. So this should download the tar file over here of Maven. Now once that is done, so I have to extract it. So tar-xvzf and the tar file name. This is a tar gunzip file, so I have to use tar-xpzdf parameter over here to extract it. Now what exactly I have got the Apache Maven directory over here, so I'm going to rename it. In order to rename it, what we need to do, we need to actually go for the particular move command. So move whatever the existing folder you have, and then I'm going to rename it with the Maven directory. Now once that is done, I'm going to the Maven directory, and this is the path or Maven_home path which is available as such over here in this one. So here all the bin directories, executables, all this stuff is there. So now I can use it like mvn_home and the same configuration just like we did in the Windows. So here also the same process we have to follow. So Java version should be let me know that which version is deployed. So 14.01 version is deployed over here. So for Java, I don't have to set up the path again here because I'm using for the installer, so I don't have to set up the path, right? So for Maven, now what exactly I have to do? I have to go to the etc profile D. Now here I'm going to put up a particular file. Now here you can see that we have the JDK file here, which means that the path variables and everything is configured as such over here. So you can see that Java_home, path, all these variables are copied here. So I'm going to also create a same file similar to this one here, but in this case what I'm going to use it that I'm going to remove some of the values. So I'm going to have some of the parameters added. So in order to do it effectively, I can do the echo command so that I can copy the things from here and I can simply put it up into the file here. So I'm going to have the path variable added up over here. Now why I'm putting up the paths? Because it's the same configuration which we did over there also. So opt/maven/bin. So all the bin directories should be added to the specific path variable. So I'm just trying to create a file called maven.sh. Just like a jdk.sh over here, I'm also creating similar kind of file over here called maven.sh. Now I'm not going in the VI mode or other editors because I just want to make you understand that how I'm copying it, the content. I'm taking the jdk.sh as a reference and putting up the details over here in this one. And then I'm going to export mvn_home over here, which is related to like opt/maven. So this is what we are going to put up over here, and then Maven. In the end, Maven, this is the file which you should be having. Now why we are using it? Because of the fact that it's being used, or it will be utilized in such a way that you can perform the changes or whatever configurations you want to perform. This will help you to set up the certain paths like a path and mvn home so that you can run these scripts as such over here. So I'm going to give the executable permissions to this one, and that's it. So now what exactly I have to do is that I have to do the source here, profile.d maven. Once that is done, I will be able to run the mvn-version over here, and the JDK part is already open, so it's going to refer to that part. So this is the way that how we configure the Maven and the JDK specifically on the Ubuntu virtual machine. So pretty much that's it for this demo. In this demo, we primarily talked about that how we can do the installation of JDK and Maven on Windows, and how we can do the similar task on the Maven on the Ubuntu virtual machine also here.
Introduction. Let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users, and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very, very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a MAVEN based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very, very important topic, which is the master slave configuration. It's a very, very important and pretty interesting topic where distributed builds is achieved using a master slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very, very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command, opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server running, up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain 2 servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very, very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using this environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system. But in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables All right, so I've just set in a Java home variable. If you see this, C colon program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C colon program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path. And if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. You also have a Docker container wherein you can launch Jenkins as a container, but I'll not get into details of that in this tutorial. All right, so what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier, and this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded, so let me just open that up. All right, so this is my downloaded Jenkins instance, or rather installer. This is maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins Home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C program files 86 and Jenkins folder. If at all you run a WAR file, depending upon the user ID with which you're running a WAR file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right. So this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right. So there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a WAR file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it'll crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. what happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it. But once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all the Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home, where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic, because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465. And reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow you to allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is the command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and MAVEN, if at all you have some MAVENs as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins' own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very simple job. All right. So job, new item, little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I have not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right, so one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins, which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. if you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into Manage Jenkins and Manage Plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I've already installed a role-based strategy plugin and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to Manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some rules for this particular Jenkins instance. So I would say first manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and MAVEN, you would need to install MAVEN and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very, very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very, very simple, repository that is there called Hello Java. And this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com, and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very, very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now, because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good, but what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this, I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right, if at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here you would see a red message saying that something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub, and then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository, and it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello, and there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a MAVEN based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MAVEN web app. It's a MAVEN based repository. As you would know, MAVEN is a very, very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a WAR file and even deploy it into some other server. For now, what we're going to use MAVEN is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need 2 other things. One is MAVEN, because Jenkins will use MAVEN. So in order to use MAVEN, Jenkins would have to have a MAVEN installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my MAVEN installed, I also need a Tomcat server. Tomcat is a very, very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download MAVEN first. There are various ways in which you can kind of download this MAVEN. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded MAVEN, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my MAVEN. So as you know, MAVEN again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, MAVEN should work. And if at all I echo m2 home, which is nothing but the environment variable specific to MAVEN home, it is already set here. So once you unzip MAVEN, just set this m2 home variable to the directory where you unzipped your MAVEN. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide these user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using these credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job, MVN, web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credential that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this and let me first run this and see if it connects well, if there's any problem with my war file or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I would go to manage plugins, available. type in container, container, deploy to container. Okay, so this would is the plugin that I would need. I would install it without a restart. Okay, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application WAR file that is already built. So I would need to configure this plugin to pull up this WAR file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the WAR file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the WAR file that is there. So ******war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MAVEN web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the WAR file that is found in this particular folder. And then, context path is MAVEN web app, use the deployer deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the WAR file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was MAVEN web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 80881. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the WAR file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and MAVEN. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he will do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very, very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP, Java Network Launch Protocol. So using this, I would ensure that the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes. Agents, and by default this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol, and I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default the configuration was disabled. So I make him random. I make him enabled, and I say save this configuration. Alright, so now I configured or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to our Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I just give an identifier saying that Windows node. I would say this is a permanent agent. I would say okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C colon program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that, and I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we're going to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad ++ is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, you have to specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials of the slave.jar along with the launch code and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my manage plugins. So this plugin is there. So hang on, backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to back up some data. And I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the MAVEN artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps and all the files that is required as a part of this. Pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of back up, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all our workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or say hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
First, we'll see how to install Java Development Kit. JDK is one of the prerequisites you need in order to run Jenkins. Then, we'll set up the JDK path in the environment variable. After that, we'll see how to download and install Jenkins on Windows. Once that's complete, we'll run Jenkins on localhost 8080, which is the default port for running Jenkins. Then we'll have a glance at the Jenkins server interface and look at some of the features present on Jenkins. Finally, we'll learn how to build and run a job in Jenkins. To download and install JDK, simply type install JDK on Google and click on the first link, which is Java SE Development Kit 8. As you can see, we get a list of downloads for JDK. Since I'm on a Windows 64-bit system, I have already installed JDK version for Windows 64. Before you install JDK, you also need to accept the license agreement. Let me show you where my JDK has been installed. First, I go to my C drive, Program Files. Under the Java folder, you find two more folders, that's JDK and GRE. Now, let's set up the path in the environment variable. Go to System Properties. Under the Advanced tab, select Environment Variables. Under System Variables, there are two more variables called Java Home and GRE Home. Java Home contains the path for JDK. I'll show you where it is. Go to JDK folder, copy the path and paste it in the value section. GRE Home contains the path for GRE. Similarly, go to the GRE folder, copy the path and paste it in the corresponding value. One more thing you need to do is set up the bin folder location for JDK in path variables. Let's see where the bin folder location is. Here it is. After setting up the location, click OK to finish the setup. Now, shall we check if Java has been successfully installed? For that, go to the command prompt and type Java-version. You can see our Java is successfully installed and it's up and running. The version we've installed is shown here. Now, let's download Jenkins on Windows. Simply type download Jenkins on Google and click on the first link. Here, we can see that Jenkins provides two types of releases, long-term support release and weekly release. As I'm interested in a more stable release, so I will go for LTS. Now, when I scroll down, I'll get an option for Windows. Once I select that, a stable installer starts to download. You can see it says, "Thank you for downloading Windows Stable Installer." So now our Jenkins has started downloading. This might take a few seconds. Till then, maybe you can catch up if you're left behind. Okay, so the download is complete. Now, let's go ahead and unzip the downloaded Jenkins file. After the unzipping has been done, we'll start the installation. Click on this folder. Click Run. Next. This is the default path where Jenkins will be installed. We don't need to change it, so we can just go ahead with next, install. After this, your Jenkins installation is successfully completed. Select finish. Yes, that's all. Now that installation is complete, let's go and explore Jenkins. Go to your web browser and search localhost:8080. You can see that it says welcome to Jenkins. So I have already created a username and password for Jenkins. I'll enter my credentials. And that's all. This is how the Jenkins homepage and interface looks like. And that's all. Signing in. Yes, so that's the dashboard, and this is how the Jenkins homepage and interface looks like. So if you're installing Jenkins for the very first time, it will ask you to install some recommended plugins. I've already installed mine, so I don't need to install them once again. Now, there are a lot of things you can do in Jenkins. Let me run you through a few of them. There's some jobs that I've already created and run. This is new item. It allows you to create a new project. So you can create a freestyle project, a MAVEN project, a build pipeline, etc. Then, going back to the dashboard, there is build history. So this section shows you the status of your build. Here you can see what's the build name, the time since the build is running, and what's the status of your build. There is another very important section called Manage Jenkins. Here you can configure your system, you can configure global security, credentials, then there's some global tool configuration. You can also download and manage your plugins. Here you can see there are 4 tabs where you have some updates, you have some available plugins, you have the plugins that you've already installed, and then there is advanced plugin as well. Now let me show you how to create and run a job in Jenkins. So coming back to the dashboard, let me select new item. We can name our job here. Let me name the job as Jenkins demo. I will create a freestyle project. So select that and click OK. This might take a few seconds. So when we have created that, here we have a number of options that we can go ahead with. You have your source code management, building triggers, building environment, and then of course some post-build actions. So that was about creating and running a job on Jenkins. Let's give some description to our job. So we have created the job. We give description something like, this is my first Jenkins job. So we will not use any source code management tool. In the build section, as you can see, there is an option to execute Windows batch command. Click on that, and here you can give your command. Let's use the echo command. I will write something like, hello, this is my first Jenkins demo. And then I'll also give the date and time parameters so that I can track on what date and time this job was built. That's it. So click apply and then save. Okay, so this job is created. Now let's build it. Go to build now. Once you click it, you can see a build history has been created. Click on that. In the console output, you can see the output of your very first Jenkins job. It says, hello, this is my first Jenkins demo. What you gave in the command box, you can see that. And you can also see the date and time when this job was created. So we've successfully created our
Hello everyone. Today we will be taking a look at Docker. It is one of the hottest technologies in the DevOps space right now. Okay, let's take a look at the agenda. We'll answer the question, what is Docker? We will discuss why we need Docker, Docker versus VMs. We'll look at Docker Hub, We'll go over the Docker basic commands. We'll discuss Docker images, and we'll see the Docker demo. So what is Docker? Docker is basically a container engine, and it allows you to run your applications inside containers. Now, until now, we've been running our applications in virtual machines. Every virtual machine used to be the base of our application, but now with the advent of Docker and containerization technologies, each application is run in a container-like logical space. So to define a container, it is a logical grouping of all the binaries and all the dependencies that each application requires, and then bundling it into a single whole and running it on top of a Docker engine. Docker is typically used to run applications, typically like microservers, which are single bundled applications. Now, they don't really depend on a lot of external factors. Now, the benefit of having applications in containers is that you don't really need to worry about the base infrastructure. You just need to make sure that you have the Docker engine running, and that will make sure that the container is running in the same way on any platform. Docker is open source, so you don't need to pay to use Docker, at least the open source version or the community edition. The enterprise version has been recently launched, and it has a few more features. But I have seen many projects implemented with the open source version, and it is more than enough for what you need to get your basic applications containerized. When we talk about Docker, it's kind of like a mini platform as a service. So in a normal platform as a service offering, what you get is just the actual thing that you need to run. So let's say you are using Elastic Beanstalk on Amazon Web Services. You get a Ruby platform on which you can run your application. Now with Docker, you get a real platform, but just the platform required to run your application. And that is more than enough to get yourself into production. Docker integrates easily with other tools, so it integrates with other ecosystem tools like Swarm, which is a cluster management system. It integrates with monitoring systems. You can monitor things on the user ports using Nagios or any other monitoring system you've been using within your existing infrastructure. You can monitor the base hosts in Docker, on which Docker actually runs using your normal monitoring tools. So why do we need it? What is the benefit of using Docker? We're really good on VMs, and we've been running them for the last decade. So what's the real need to go to Docker? Well, the first thing is you get really efficient utilization of your resources. Now, let's say I've got 10 VMs, and I'm running 10 applications on VMs, and things are good, but the only problem is VM number 4 is at 50% utilization. So I'm actually wasting half of capacity on VM number 5, and on VM number 6, say I'm just using 40% of the entire power I have. So in that case, a lot of the provisioned capacity goes to waste. Now, in order to use that space and capacity in a more efficient way, you need to have some sort of mechanism which abstracts the base hardware allocation and the application. Now, Docker forms the best combination for that. So it allows you to run your applications in containers, and at the same time allows you to optimize your resource utilization. So let's say you're on 10 VMs earlier and you were running 10 applications, and when you move to Docker and you've Dockerized your applications, you can use those same 10 VMs and on top of those VMs run a cluster of Docker containers, and those 10 VMs now will be available as a whole to Docker Swarm or any other cluster management system, and you can run all your applications across those 10 containers. So in effect, those 10 VMs would be available as a whole for the containers to easily run anywhere. You can actually bump in more containers on the same number of VMs. So let's say you were on 50% utilization and you want to increase the utilization, and you can actually run more containers, so you could actually get up to 90% utilization of the same hardware. So with this, you easily get scalability, since you can scale up or scale down any cluster management system. So if you're running Docker Swarm, for example, you can scale up your containers to any number just by a single command. You get the portability of the cloud as well as Docker containers. Let's say you are on AWS Cloud and you want to move to Google Cloud. You can import your containers to Google Cloud just by running a Swarm cluster there and then porting the image, and that's it. You don't need to worry about any networks for anything else. You just run your application on top of Docker Swarm or Docker Engine. Now, with this portability, you get the advantage of having multiple environments, and with those multiple environments, you can have disaster recovery in place. Disaster recovery will give you a high availability and your business will never be down. That's one of the biggest advantages of Docker, and you can easily set up DR zones in your environment. Now, let's compare Docker with VMs. Docker's fast. You can run a Docker container like in 1/120th of a second, whereas a VM takes almost 3 minutes to boot up if it's a GUI VM. If it's a CLI VM, it takes almost 1.5 minutes to boot up. So Docker containers are lightweight since they follow the layer file system approach. Any Docker container, which is like a base image, would be around 120 to 150 megabytes. Now, if you look at a VM OVF file or a VMDK file from VMware, you'll find that it's almost 2 gigabytes for the CLI version, and for the GUI version, it's more than 4 gig. Docker containers are portable. You can easily port them by committing them to a Docker hub and then importing them elsewhere. VMs are not that portable. So let's say you've got a VM in a VMware sphere in your house, and you really have to import that entire image using a PIM drive or some sort of network share, and it takes like 4 or 5 hours to do the transfer. So the portability aspect for the VMs is less desirable. Let's talk about Docker Hub. Just like you have GitHub for code, there is Docker Hub for Docker containers. Now, Docker Hub is used to store Docker images and share them as well with the community. Docker Hub has both open source and pay repositories. So it's an open repository managed by Docker inclusive. So they have it for the community. So you can get one private repository and unlimited public repositories for free. On the Docker Hub, you've got official images of almost every software on Earth, like Nginx, Apache 2, Enterprise Edition images. It's a hosted solution for private repos. So if you pay Docker Hub for private repositories, you can get a cloud-hosted solution there. So you don't need to manage a local repository in your infrastructure. There are some Docker basic commands, which we will take a look at in the demo. There is Docker PS that is used to show how many containers are running. Docker pull, which allows you to see and pull images from the Docker Hub. Docker run is used to run Docker containers. Docker images will show you the images you have in your local repository. Docker attach will attach to the shell of a running container. Docker stop will stop a running container and will start a stopped container. Let's take a look at the demo. So I've got a Linux machine here on Ubuntu 16.04 command line version, machine ready, set up. It's running on a virtual box, and I'll be using the terminal on my MacBook to access the machine. We'll proceed with the installation of Docker on that machine first of all. Then we'll pull some images from the Docker Hub. We will also try to run some containers, and then we will look at the usage of some normal commands. Then we will try to make some changes in the image and commit to the local repository and push it to the Docker Hub. So that will be all for the demo. So this is my Ubuntu 16.04 image. So you see LSB_release-A. You see it's Ubuntu 16.04, codenamed Xenial, and it's the latest LTS release. We'll be using apt, first of all, to install a couple of dependencies which Docker has. So I'll say apt-get install apt-transport -https ca-certificates curl software -common -properties -y. The -y is used as a yes to automatically accept the agreement. Pretty much all of these are there by default in the installation of Ubuntu, so you don't really need to worry about those, but just as a security check, we did that. Now the next step, we are going to download the GPG key of Docker from the official repository, so they host it at download.docker.com. The reason we need to have that is that we want to make sure we don't get any spoofed packages. So we do a curl -f. So I'm doing it in the silent mode using these switches because I'm going to pass that the apt-key add command. It's hosted on https download.docker.com /linux/ubuntu/gpg, and I'll pipe it to the apt key command. So I'll say apt-key add -. So what this will do is get the GPG key from the Docker repository and add it to the local apt cache. Okay, have pressed it. It should say okay. So this means the key is added now. Now I want to add the repository for the Docker installation. There's a remote, but my local installation doesn't know there's a remote repository. So I'll be using the add-apt-repository command to do that. So I'll say add-apt-repository to do that. And then I'll say deb arch equals AMD 64 https download.docker.com/linux/ubuntu, then $lsb release -cs, and then stable. This command will add the repository to my etc apt sources.list. So if I open the file and etc apt, if I open the sources.list file, you'll see so I've added the AMD 64, which is the 64-bit version, since my machine is 64-bit. So if I do a uname-a, it says x86-64. So I want a 64-bit machine, and that's why I've added the 64-bit repository of Docker. Next step I want to do is update my apt caches, because I want to get the latest package indexes. So I'll say apt-get update-y. After updating the local cache, I need to restore the Docker Community Edition, so I'll use the apt command again. apt-get install docker-c-y. This will install the Docker Community Edition on my local machine. It will fetch all the repository packages. Now Docker's installed on this machine. Let me check and see what version of Docker I have. So I'll do docker -version. So you see I have Docker version 17.03.1 Community Edition, build C6D412E. The next thing I need to do is I need to go and run a Hello World container, because that's like a health check. So I'll say docker run hello-world. We'll do a couple of health checks in the background. Now you see it says unable to find the image locally, pulling file system layer from Docker Hub. And it gives me this nice clean output that says hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. So basically it did a whole lot of health checks in the back end to contact Docker daemon. Then the Docker Hub was contacted, the image was downloaded, so everything seems to be fine now. Now I'm going to download a couple of images there, so the first thing you do is you search for those images. So I'll search for the Ubuntu image, so I'll say docker search Ubuntu. So you see a lot of images are out there, of which only the first one is an official one. So you see this is official, okay. So I'll download all 4 major versions. So I'll say docker pull Ubuntu. This will pull the Docker Ubuntu image. So you see it's pulling down the layers. I'll pull the Fedora image. These are the 4 most popular versions. So I'll say docker pull Fedora. Docker pull Debian. And then docker pull CentOS. That's the 4th one. So all of these images have been pulled from the Docker Hub. Now let me give you a quick look at the Docker Hub. So if you go to hub.docker.com, you go to Explore, you'll see almost every major software is in there. Nginx, Redis, BusyBox, Ubuntu, Alpine, Registry, MySQL, Mongo, Elasticsearch, Logstash, Node, Hello World, Swarm, HTTPD, everything. So I've pulled 4 images here. So if I do a Docker images, it will list out all the... So in addition to the Hello World, I've got 4 more images, which I've pulled down. So you see, it shows me the tags, which is the latest. There's an image which corresponds to a unique image ID on the Docker Hub. It shows me the created date, 6 days ago, 12 days ago, whatever date image was created, and the size. So you see the size is considerably small. 119 meg, 100 meg. The Hello World is just 1 KB. CentOS is just 193 MB. Fedora is 231 MB. The next thing we're going to do is I want to run the containers. So let me run the Ubuntu container, so I'll say docker run -ti Ubuntu. So this will run the Docker Ubuntu image in interactive mode. So I'll be able to switch to this container. So you see the prompt will change now to root at 480. So I'm inside the container now. So I'll do a free -m, and the container has the same amount of memory as the base machine. So let me go to the base machine. So I'll open up a session to the base machine here. Okay, now in this image, root at this is the container. If I do a free hyphen here in the base machine, you see almost the same amount of RAM is free. So this means Docker containers use the same RAM that is available on the base machine. Now I'm going to do a docker ps-a here. It shows me that there are 2 containers running. One has the Hello World container, which I ran 4 minutes ago, and was used just as a health check. And then you see there's a Ubuntu container running, and its name has been given randomly by the Dr. Damon as Happy Pasteur. So this container is running in the background, and it's up in this VM. Now we're going to stop this container using the docker stop command. So I'll say docker stop, and then the container ID. This will stop the containers. So if I do a docker ps-a, you see it shows that it has exited, but I can restart this container by doing a docker start. And then I can attach the command line of that container using the docker attach command. You see I've restarted it and I was able to attach it. Now let me exit from this container and let me remove all the containers. So the command to remove all the containers is docker rm and then the container ID. Now, you can see I have 1 container remaining. I've removed all of them at once by just doing the docker rm. And then in brackets, I'll be placing docker ps-aq, which will get all the container IDs. Now, if you run it as a standalone, you'll see docker ps-aq gives you all the container IDs. Now, let me run 1 container in the background once I do docker run -ti-d Ubuntu. So you see it's running in the background. So if I do a docker ps-a, there's a container, agitated Euler, running in the background. I can attach to that container by using the docker attach command. Docker attach and then the container ID. Now let me update this container and make some changes so I can commit to the Docker Hub. So I'll say apt-get update -y. This will update my Docker container to have the latest package indexes from the Ubuntu repositories. Now I'll do an apt-get, so I'll install the Apache web server on this. So I'll say apt-get install Apache 2-y. This will install the Apache 2 web server actually on this container. I'm doing this because I want to save the state of this container on the Docker Hub. So this is downloading the Apache 2 from the remote repositories. Then I'll start the Apache service. So I'll say service Apache 2 start. So if I do a service Apache 2 status, you will see it is running. Now the next thing I want to do here is exit from this container and then try to commit it. So I'll use the docker commit command and to save the state of this container. So you see docker ps-a. This is the container for which I'll save the state for. So I'll say docker commit-m. This is the commit message, so I'll say installing Apache web server. And then I'll say author name Amir, and then container ID and the name, which I won't put. Now, there's one thing which we need to take care of here. You have to make sure that your image has the following formatting. It should be your username on the Docker Hub, Amir Ahmad 170, / whatever your container has. So I'll say Ubuntu-Apache 2. Now, when I commit this container, it comes into the local images list. So if I do a Docker images, you can see it's here. Now, I've got to push this to the Docker Hub, so I'll say Docker login-u. Log into the Docker Hub from the command line using my username. So I'll say docker-u Amir Ahmed 170. I'll give it my password. So I'm logged into the Docker Hub now. It says Docker login succeeded. Now I can commit that image, so I'll say docker push. I've already committed it, so I'll push it now. So I'll say docker push and then the image ID. So if I just do a push here, it's doing this. But in the meantime, if I go to my dashboard, I already have two things here. And in a moment, you'll see one more here. So it's pushing all the layers of the image. And then once you push this, I can just remove my local thing. So when I refresh this here, you'll see a third image coming up here. Actually, it has over it in the one I already had. So let me just delete and repush this. I'm going to clean up my Docker Hub here. Delete. I'll delete this one as well. Delete. Delete. Okay. Now if I push again, you'll see it will create a new image here in my Docker Hub. It will take some time to do that, but that would be a confirmation that the image has been pushed from my Docker machine here. So it's pushing 137 MB of the image layer, the top layer. So you see this is pushed. So now the basic idea behind this pushing was I really wanted to keep this saved in the remote Docker Hub. So I'm going to remove all my local images. So I'll say Docker images. Okay, I'll remove all of them. So I'll say Docker. First, I'll clean up my container. So I'll say Docker RM. So there's no container running, so I'll remove all the images locally. So I'll say Docker images, and then I'll do a docker rmi-f. So I'm removing it forcefully. But I'll do the single command remove, so I'll say docker images -aq. This is a single command remove. It basically gets all the image IDs in this command, so let me show you this. Right now there is no image, but it will put all those image IDs here and forcefully remove all those images. So if I do a docker images, no docker images there. If I do a docker ps-a, no container is there. Now let me run the container from here. So I'll pull the image first using this command. So the beauty of Docker Hub is that it gives you a command for pulling the container. So I'll do docker pull Amir Ahmed 172 / Ubuntu-Apache 2. So it statically goes to the Docker Hub. It's pulling the layers from there.
Desktop for Windows, so you can go for the stable or you can go for the edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the edge there. So you just have to double click on the installer, and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more, and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there. Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory, to the downloads, and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on OK. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed. So you can run like Docker version, you will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part.
So before we begin, let me give you an intro to Docker. So what is Docker? Docker is a tool which is used to automate the deployment of applications in lightweight containers. So when I say containers, I mean a software package that consists of all the dependencies required to run the particular application. And when you deploy containers, you're basically providing the capability for the application to run in any kind of environment. So Dockers have multiple features, some of which are that multiple containers can run on the same hardware. It has very high productivity when compared to virtual machines. It maintains isolated applications and has a very quick and easy configuration process. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install Docker. Enter your password. So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version. And as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we'll pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the two hello worlds which is created 2 minutes ago is also displayed here. And the first hello world, which has been created a minute ago, is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state. And with that, we come to an end of our Docker installation.
So we're going to go through a bunch of things today around Kubernetes. We're going to cover what Kubernetes is and why you should be using it, along with the features of Kubernetes. We're also going to take a little bit of a look at Kubernetes versus Docker Swarm, as the two technologies do tend to get referred to quite frequently. And then we're going to do a deep dive into the actual Kubernetes architecture itself and how Kubernetes runs and operates within your network. And then finally, we're going to look at some Kubernetes use cases of how you can actually apply best learnings that other companies have used with Kubernetes. We'll finish everything off with a demo where we actually step through and use some of the actual codes that you can actually use to run from your terminal window to actually activate Kubernetes itself. So with that said, let's jump in. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network, or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment, so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution, that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need, how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers, and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster is very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. And you really want to let Kubernetes do this, because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right hand side, we have our nodes and the pods within our nodes, and within those pods are the containers. On the left hand side, we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left hand side, we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you are probably not surprised are using Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They were able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's life cycle rather than to create the pods directly. We have a selector, which is an expression matched label label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filter, organize, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password. And this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https. And this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency. And the way we do that is write the command sudo apt install docker.io. I've got a typo, correct that quickly. And put in y, so for yes, and we continue. And that's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. All right, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. And we're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc/apt/sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt-kubernetes.io/kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do etc/apt/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. Alright, so we have installed kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. Alright, so that's all done. Alright, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com corios flannel master documentation cube-flannel.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube./config. And then the final one will be sudo chown $open paren id-u close paren colon $open paren id/-g close paren $home/.cube/config. Alright, now we're going to go ahead and deploy, and let's see. Oh, yeah, I think I have a typo in my command here. Yep. Oh yeah, I did have a typo, and so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network. And so we're going to do that by writing the command sudo kubectl get pods -all -namespaces. And it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service, and we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80, so it's going to be nginx-app --port equals 80 --environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app --port equals 80 --name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
Now, the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates. And then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io.
you have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt-get install curl. So you have to select Y, and this will take a few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key, and then we have to add it using sudo apt-get add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now moving forward, now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl, and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that. Sudo swap off -a. Now let's go ahead with the initialization. Sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster, we have to use these three commands. Let's just copy paste it. Okay, that's done. So, moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo, I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources, and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often, and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks, and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the 2. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go, your Apache server is installed and your web page is hosted. So that was very simple, wasn't it? If you have any doubts about the procedure or any other part of the tutorial, please post your doubts in the comment section below and we'll get back to you as soon as we see them. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using two systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML is extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root is called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically a Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task, and the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats, and then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible. So before we begin, let's have a brief look at all that you learned today. First, we'll get to know why should we use Chef and what exactly is the Chef. 2 of the most common terms used with Chef: configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy the product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure, but in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by Opscode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D, and so on need to be well aware when the change is made as to why it was made, what was the change made, and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here, the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. we don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code, and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something, and at his 10th command he realized the very first command he wrote, there was something not right there, well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it, and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable, and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And our final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node, and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine, and 2 nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the Ohai service. The Ohai service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is the hosted Chef. With hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these three machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using two virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have two machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK installation. Go to the first link, which is your Chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7, so my operating system version is 7, so I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And Chef DK is downloaded. Next step, we need to install it. And this is the version of the Chef DK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a Chef repository. So within that, we'll have a folder for holding all our cookbooks, and within our cookbook, we'll write our recipe. So we start with the directory for Chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK. We have a Chef repo folder here. And let's check the contents of the Chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample, and tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes we have default.rb. So we'll be editing this default.rb to create our recipe. Okay. So let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server. Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you got to download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is, go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type ifconfig. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done, go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password. And then finally, you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Now I'm using my Oracle VM VirtualBox Manager, as you can see here. I'll have two machines, the master and the node. Both of these are CentOS 7 machines. As of the server, we'll be using this as a service on the cloud. So let's begin. Let's have a look at our master system first. This is my master system. The terminal's open over here, and the terminal color here, it's black background with green text. And this is my node system. So the terminal here has a black background with white text. So you can differentiate between the both. So we start at our master system. The first thing we need to do is we need to download the chef DK. So you can write wget, which is the command for downloading, and then go to your browser and just type chef DK here. The first link. So here you have different versions of chef DK. Depending on the operating system that you're using, you need to select the appropriate one. I'm using the Red Hat Enterprise version, and that's number 7. So I'm using CentOS 7. So this is my link for downloading chef DK. Just copy this link and go back to your terminal and paste it here. So your chef DK is being downloaded. This will take a while. Right after we download the chef DK, our next step is to install it on our system. So our chef DK is downloaded. Now let's install it. So guys, this is the version of chef DK that you have downloaded. So make sure this is exactly what you type down here too. So great, our chef DK is installed. So basically our installation for the workstation is done right now. But just so you understand how the flow is, we'll also write a sample recipe on our workstation. So before we do that, let's first create a folder. My folder name is chef repo, basically the chef repository. And let's move into this folder. Okay, so we're in. Next, what we need to do is, as I mentioned earlier, all your recipes will be within a cookbook. So let's create a folder which will hold all our cookbooks. And let's move into this too. Okay, so our next stage is to create the actual cookbook within which we'll have our recipe. So the command for creating the cookbook is chef generate cookbook sample. So sample is the name of my cookbook. So guys, please notice here, cookbooks is the directory that I created, which will hold all our cookbooks. And here cookbook is the keyword. So sample is that one cookbook that we are creating under our folder cookbooks. And our cookbook's being created. Great, so that's done. Moving into our cookbook. Okay, so when our cookbook sample was created, automatically there's this hierarchical structure associated with it. So let's have a look at this hierarchical structure to understand what our cookbook sample exactly is before we move on. So the command for looking at a hierarchical structure is tree. So as you see here, within our cookbook, we have a folder recipes, and under this there's the default.rb recipe. This is where we'll be creating our recipe. So we'll just alter the content of default.rb. So let's move on to finally writing our recipes. So we'll move into this recipes folder first. So now we'll open our recipe default.rb in gedit. So the recipe for this particular demo is to install the HTTPD package on our client node. That is basically your Apache server. And we'll also be hosting a very simple web page. So let's begin. So the recipes in chef is written in Ruby. So I'll explain you the recipe in a while. Okay, so the first line is where you install HTTPD. The second line for service is where you start or enable the HTTPD service on the client node. That's our first task. The second part's where we need to create our web page. So this is the part where your web page will be stored. If you have written any HTML file previously, you know that this is probably like a default path where our web pages are created. Yep, that's it. So this is the content that will be displayed on your web page if everything works right. And I'm pretty sure it will. So now we can save our recipe, and that's done. Close your gedit. So now that we have created the recipe, all our work at the workstation is completed. The next thing we do is we move on to the server. So as I mentioned earlier, we'll be using the server as a service on the cloud. So go to your browser and here just type manage.chef.io. So this is the homepage of your Chef server. Click here to get started. We need to first create an account for using the Chef server. This is completely free. We just need to give our email ID and a few other details. It's in fact a lot like creating an account on Facebook or Instagram. Fill in all the details. Check the terms of service box. So the next thing you need to do is go back to your inbox and verify your email ID. So I have my inbox opened here on my Windows machine. So this is my inbox. You would have received a mail from Chef Software. Just click on this link to verify it and create your password. And that's done. So let's continue this on our workstation machine. So type in your username and password. So the first time you log into your Chef server, you'll have this pop-up appear where you need to create a new organization. So create your organization. So this organization is basically the name that will be associated with a collection of the client machines. First thing you do, go to your administration tab and download the starter kit. So guys, when you're doing this part, make sure that you're on your workstation. That is, you're opening your Chef server on the workstation because you need this folder to be installed here. You save the file, so this gets downloaded. So the Chef starter kit is the key to connecting your workstation with the server and the server with the node. So basically it has a tool called Knife, which we'll come across later in our demo. This Knife is what takes care of all the communication and the transferring of cookbooks between the three machines. In our case, the two machines, the workstation and the node, and the one server. So let's go back to our root directory. So our Chef starter zip file is within our downloads folder. What we do first is we'll move the zip folder into our cookbooks folder and then we'll unzip it there because our cookbooks folder is the one that contains the recipe and that is where we require knife tool command to be present so we can send these recipes over to the server. So we'll just check the contents of our cookbooks right now to ensure that our Chef starter.zip file is within the cookbooks. Yep, so it's here. So next thing we do is we need to unzip this folder. Great, so that's unzipped. And this means that our workstation and our server are now linked. So we just need to use the knife command tool to transfer or to upload our recipes, which we created on the workstation, onto the server. So before we execute this command, we need to move into our cookbooks directory. As you know, that is where we unzipped our Chef starter kit. So that is where our knife command is present too. And now let's execute the knife command. So it's knife, cookbook, upload, and sample. So as you probably recall, sample is the name of the cookbook that we created. And within sample, we created our recipe, which is default.rb. So we're uploading the entire cookbook onto the server. Execute the command. Great, so our cookbook's uploaded. Now let's check this on our server. So move to your browser where you opened your Chef server and go to policy. So here you go. This is the cookbook we uploaded sample and it's the first time we uploaded it. So the version 0.1.0, the first version. Now what you would notice is if you go to the nodes tab, there are no nodes present. So if you have no nodes, you basically have no machine to execute your cookbooks. And the nodes are not seen right now because we have not configured them yet. So that's the next thing we need to do. All this so far was done on your master machine. Now we'll move on to the node machine. So before moving on, let's just check the IP of our node machine. So that's our IP. Note this down somewhere. And now we move back to our workstation. As we already saw that we uploaded a sample workbook, next thing we need to make sure that our server and node are able to communicate with each other. So again, we use the knife tool for this too. The command here is knife, bootstrap, and enter the IP address of your node, which we just checked. We'll be logging in there. So we'll be using the node as the root user. And then we also need to specify our root password for the node. And we give a name to this node. So this is the name by which we'll be identifying our node at the server. So as you've probably noticed here, we're using the term SSH, which is a secure shell. So it basically provides a channel of secure communication between two machines in an unsafe environment. Okay, so it's done. So if your command has executed right, which in our case, as we can see, has, our chef server and our chef node must be able to communicate with each other. So if this is so, we should be able to send the cookbook that we previously uploaded from our workstation onto the server, now from our server to our node. So to do that, before we move on to the node machine, we need to go back to our chef server. Let's refresh this page. And as you see here, previously under the nodes tab, we did not have any node mentioned. Now we do. Chef node, which is the node we wanted to identify our node by, which is a CentOS platform. And that's our IP. So it's active for 2 hours. That's the uptime. Last check-in, the last time we checked into our node was a minute back. And yeah, that's pretty much it. So now we'll create a run list and we'll add a sample to this run list. So just click on your node. And you'll see the small arrow here in the end. Click on that, edit run list. And under available recipes, we have a cookbook sample present. So drag and drop this to the current run list and accept it. Okay, so now that we updated our run list, our recipe is sent to our node. What we next need to do is that we need to execute this at our node. So now we'll move on to our node machine. Chef client is the command to execute your. So while this recipe is executing, you can see what exactly is happening. Our recipe was to install HTTP package first, which is your Apache server. So the first line, that's done and it's up to date. The second line, it's enabled. Third line, the service is started. And the fourth line is where your contents created for the web page at this very location. So by the look of this, everything should work fine. So how do we check this? We can just go to our browser and in the search bar, just type localhost. And there you go. So our HTTP package, which is the Apache server, is installed and our sample web page is also hosted. Congratulations on completing the chef demo. If you have any doubts regarding the demo, please put them in the comment section below and we'll definitely reply to you. So I hope you guys really liked the video. If you did, please hit the like button. Also subscribe to our channel. If you haven't so yet, we have more installation videos coming up. So stay tuned. Installation procedure for the configuration management tool Puppet. So what exactly is the use of Puppet? If you consider the scenario of an organization which has a very large infrastructure, it's required that all the systems and servers in this infrastructure is continuously maintained at a desired state. This is where Puppet comes in. Puppet automates this entire procedure, thus reducing the manual work. So before we move on to the demo, let me tell you what the architecture of Puppet looks like. So Puppet has two main components. You have the Puppet master and the Puppet client. The Puppet master is where you write the configuration files and store them, and the Puppet client are basically those client machines which require the configuration. In case of Puppet, these configuration files that you write are called manifests. So let's move on to the demo. So here are my two machines. The first is the server system, which is basically your master where you'll write your configuration files, and the other is the node or the client system. So let's have a look at both of these machines. This is my node system. The terminal is open here and the terminal has a black background with white text. And as of my server or the master machine, it has a black background with green text. So we start at our server machine. The first thing that we need to do is we need to remove the firewall. So in a lot of cases, there are chances that the firewall stops the connection between your server and your node. Now, since I'm doing a demo and I'm just showing you how Puppet works between two virtual boxes, I can safely remove the firewall without any worries. But when you're implementing Puppet in an organization or a number of systems on a local network, be careful about the consequences of doing so. So our firewall is disabled. Next thing that we do is we'll change the host name of our server system. Now while using the Puppet tool, it's always advisable that you name your server's host as Puppet. This because the Puppet tool identifies the host name Puppet by default as the host name for the master or the server system. Let's just check if the host name is changed successfully. Yep, so that's done. So as you see, still localhost is appearing as the host name. So just close your terminal and start it again. And you see here, the host name has been changed to Puppet. Okay, so the next thing that we have to do is we install our Puppet Labs. Make sure your system is connected to the net. Right, so Puppet Labs is installed. Next, we need to install the Puppet server service on our server system. Now that our Puppet server service is installed, we need to move into the system configurations for our Puppet server. So the path for that is etc sysconfig Puppet server. So this is a configuration file for the Puppet server. Now if you come down to this line, now this line here, this is the line which allocates memory for your Puppet server. Now you must remember that Puppet is a very resource extensive tool. So just in case, to ensure that we do not encounter any errors because of out of memory, we will reduce these sizes. So as of now, we have 2 GB allocated by default. We'll change this to 512 MB. Now in a lot of cases, it may work without doing so, but just to be on the safer side, we make this change. Save it and go back to your terminal. We are now ready to start our Puppet server service. The first time you start your Puppet server service, it may take a while. Next, we need to enable this. And if your Puppet server service is started and enabled successfully, this is the output that you would get. In case you're still not sure, you can always check the status at any point of time. And as you see here, it's active. So everything's fine as of now. Next thing we do is we'll move on to our agent system or our client or node system. So here too we'll have to install Puppet Labs, but before we do so, we need to make a small change in our host file. So let's open the host file. Yeah, so this is our host file. We need to add a single line here which specifies our Puppet master. So first we put our Puppet master's IP address followed by the host name, and then we'll add a DNS for our Puppet server. So let's just go back to our server system and find out its IP address. And that's my IP address for the server system. Now the host name of our Puppet server and a DNS for it. Save this file and return to your terminal. So now we can download our Puppet Labs on the node system. It's the exact same procedure that you followed for downloading Puppet Labs on your server system too. So in my node system, the Puppet Labs is already downloaded. So the next thing is we need to install our Puppet agent service. So Puppet is a pull type of configuration tool. What this means is that all your configuration files that you'll be writing on your server is pulled by the node system as and when it requires it. So this is the core functionality of the agent service which is installed on your client node or agent system. So my Puppet agent service is installed. So next I'll just check if my Puppet server is reachable from this node system. So 8140 is the port number that the Puppet server must be listening on. And it's connected to Puppet. So that guarantees that your server is reachable from the node system. So now that everything's configured right, we can start our agent service. So guys, you would have noticed that the command for starting the agent service is a little more complex than the command for starting your server service. This is because when you start your agent service, you're not just starting a service, but you're also creating a certificate. This is the certificate that will be sent over to your master system. Now at the master system, there's something called the certificate authority. This gives the master the rights to sign a certificate if it agrees to share information with that particular node. So let's execute this command, which does both the function of sending the certificate and starting your agent service. So as you can see here, Our service is started successfully. It's in a running state. Now we'll move to our master system or the server system. So first we'll have a look at the certificates that we received. The certificate should be in this location. So as you can see here, this is the certificate that we just received from our agent service. So this here within quotes is the name of our certificate. So next, when we are signing the certificate, this is the name we'll provide to specify that this is the particular certificate that we want to sign. So the minute we sign a certificate, the node that sends the certificate gets a notification that the master has accepted your request. So after this, we can begin sharing our manifest files. Now here's the command for signing this certificate. Okay, so our certificate is signed, which means that the node's request is approved, and the minute the certificate is signed, the request is removed from this list. So now if we execute the same command as we did to check the list of all the certificates, we will not find this certificate anymore. Let's just check that. So as you see, now there are no more requests pending because we have accepted all the requests. If you want to have a look at all the certificates that is signed or unsigned, you can use the same command with the addition of all. And all the certificates received so far will be listed. As you can see here, the plus sign indicates that the certificate request has already been accepted. So now that our certificate is signed, the next thing we do is we'll create a sample manifest file. So this is the path that you create your manifest files in. Our file name is sample.pp and our file is created. So right now we have no content in this file. We'll just check if the agent is receiving it, and once that's confirmed, we'll add some content to the file. So let's move to our agent system. Now this is the command to execute at the agent system to pull your configuration files. So our catalog is applied in 0.02 seconds. So now that the communication between our agent system and our master system is working perfectly fine, let's add some content to the previous placeholder file that we created on our master system. So now we open the same file in an editor. Okay, so we are going to write a code for installing the HTTPD package on our node system, which is basically a Apache service. Node, and then within quotes insert the host name of your node system. So my node system's host name is client, the package you wish to install, which in our case is HTTPD, and the action to be performed, and that's it. A very small and simple code. Save this file. Now let's go back to our node system and let's pull this second version of the same configuration file. So every time you execute this command, as we did previously too, what happens is that the agent service, so the agent service basically checks on your master system if there's any new configuration file added or if there's any change to the previous configuration file made. If so, then the catalog is applied once again. So now our catalog is applied in 1.55 seconds. So now to check if our catalog served its purpose, let's just open our browser. Just type localhost here. And as you can see, if your HTTPD package has been successfully installed, the Apache testing page will appear here. So we come to an end of our installation and configuration of the configuration management tool Puppet. If you have any doubts regarding this, please post them in the comment section below and we'll definitely get back to you. So what will we learn today? Today you'll learn about why we should use Puppet, what exactly is Puppet, the Puppet architecture, how Puppet works, and finally we'll have a demo on the installation of Apache on our node. So let's begin. Why Puppet? So consider the scenario of an MNC. The MNC puts together the small team of system administrators. They're responsible for taking care of the infrastructure of this organization. Now this infrastructure could consist of data centers, server centers, and many such components. Fortunately for the MNC, they were doing extremely well. So the number of clients kept growing consistently, and with this came a boom in the infrastructure size. Now here is where the problem came in. With such a large infrastructure, the small team that they put together in no way could manage this. So what do? The solution seems pretty simple, right? Just increase the size of the team. Sure, we'll increase the size of the team. But when do you think we can put an upper limit on this size? When do we get to stabilize this team? So here is where Puppet comes in. With Puppet, a small team is enough to take care of this large infrastructure. This is because the data centers, server centers, all of them can be updated in a matter of seconds with Puppet. Entire load of doing so has now shifted from the team onto the tool. Not only this, with Puppet, if servers do fail, and there's a very high chance of servers failing when you're considering an organization the scale of an MNC, Puppet can instantly roll them back to their previous working states. And if that wasn't enough, Puppet also provides the capability to deploy servers on demand and enforce security on them. Now all of this is done through simple coding which is written in Ruby. We'll look at how Puppet works more. So now that we know why we should use Puppet, let's have a look at what exactly is Puppet. So first and foremost, Puppet is a configuration management tool, as I already mentioned in the beginning of this video. So this simply means that Puppet ensures that all your systems are maintained at a consistent state. So consider that you want to deploy a number of servers. Now you require these servers to be identical. If this task is given to a human, there's a very good chance that those systems will not be identical, or some of them may even fail. Humans are prone to errors, you cannot blame them. So Puppet ensures that all these servers are deployed on time and they are identical. Secondly, Puppet is also a deployment tool. This simply means that Puppet has the capability to deploy your applications, your services, your softwares, all of this on your nodes automatically. And finally, Puppet implements infrastructure as code. Now this term infrastructure as code is a very important one when it comes to the DevOps approach. You would have noticed this term being used in our previous video on Chef 2. If not, you can always click the top right corner to know more. So what does this term infrastructure as code mean? Infrastructure as code simply means that all your policies, your tasks, your instructions, everything is written in coded format. So in case of Puppet specifically, all of this is written in the Ruby language. So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet Client. Of course, these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with this system A. If it does, it signs the certificate and this signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first 3 stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifests or even could be your files. So what happens after this request? After this request, the Factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and it can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes, your systems will be configured. And we reach the final and the most exciting part of our video, which is the hands-on. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines, and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it will sign this certificate. So once your master or the server signs the certificate, you can write your manifest. So the manifest are just the code for configuration, and once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your cat logs, because as you know the manifests are compiled into cat logs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. $512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Sign certificate request. Here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client.
What is that you should be expecting from this video? Let's see what is Selenium. Whenever we are learning about any tool, it's good to know a little bit brief history of it. So we will look into how Selenium has evolved over years to become the most popular web application automation tool and why use WebDriver. And then we will understand what is Selenium driver. While we learn this, I will also be touching upon some drawbacks of manual testing and how automation helps. And then a deep dive into architecture of WebDriver. As you know, every automation tool has its own advantages and limitations. So we will be understanding the limitations of Selenium WebDriver and how we work around this. And then I will demonstrate the WebDriver in action, for which I will use a simple web application use case to automate. So let's get started. So before we talk about Selenium, let's understand a few drawbacks of manual testing. Let's take an example of a very simple use case. As a user, I want to log in to my web application using username and password. A very simple use case, and it's a very common use case for any kind of web application you're working. So as a tester, what do? I need to write multiple test cases to test this use case. So I can use multiple data sets like valid credentials, invalid credentials, null values, and so on to test this particular use case. And then what you do, you start executing the test cases one by one. You find bugs. Then your developers fixes them. and then you will need to rerun all the test cases again and again until all the bugs for this use case are fixed and your application is ready to ship. Now look into this. Now this brings us to the first demerit of the manual testing, which is what? If one has to run test cases with 100 transactions and repeat them again and again, this is going to be a very time consuming process and very boring. Also, it is more error prone since it's done manually and human mistakes are bound to happen. The third challenge is the scope of manual testing itself is very limited. For example, say regression testing. Ideally, you would want to run all the test cases which you have written, but since it's a manual process, this is going to be very tedious to do. And also, you would not have all the luxury of time to execute all test cases. So what do? You start picking up those test cases which are very important to be run. And that way, you are kind of limiting the scope of your testing. Also, working with large amount of data manually is going to be impractical. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on your application under test. And all these things, manually, it is very difficult to perform. And it's not feasible also. And to submit all this, creating manual test reports after running all the tests. Who wants to really do that? And again, another level of challenge here is, say if you're working on an agile model where code is being churned out by developers, the testers are building their test cases, executing them as and when the builds are available to them. This happens iteratively, and hence you will need to run all those test cases which you have written multiple times during your development cycle. And doing this manually definitely is going to be very tedious and boring. And is this the effective of doing it? No. So what do? We automate it. So this tells us why we want to automate. 1, for faster execution, 2, to be less error prone, 3, to help frequent execution of our tests. So there were many tools available in the market for automation. One such tool was Selenium, and that brings us to the slide, Advent of Selenium. So much before Selenium, there were various tools in the market like RFT, QTP, just to name a few popular ones. So Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks. He was kind of working on a web application which needed frequent testing, and he realized the inefficiency in doing manual testing of his application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and then he named that as JavaScript Test Runner. He made this open source, which was later renamed as Selenium Core, and this is how the Selenium came into existence. So with this brief history of Selenium, let's understand what is Selenium and what are its main features. Selenium is the most popular and widely used automation tool for automating web applications. It enables us to test web application on different kind of browsers like Internet Explorer, Chrome, Firefox, Safari, Opera, and so on. And also they introduced support for Edge browser after Microsoft introduced it. Selenium is a set of tools and libraries to facilitate automation of web application. It is not a single tool. It has multiple components, and those we will be seeing in some time. All these tools together help us test the web application. So Selenium is open source and it is platform independent. This is the biggest reason why people are preferring this tool, because it is free of cost. QTP and RFT, which I just talked about, are a chargeable one. Selenium scripts can run on any platform because Selenium is primarily developed in JavaScript. So it is platform independent. Well, as you know, it's common for manual testers not to have in-depth programming background. So Selenium has a record and replay back tool called the Selenium IDE, which can be used to create a set of actions as a script and to replay that script. But this is mainly used for demo purpose. Why? Because Selenium is such a powerful tool that you should be able to take advantage of all its features and not just be with a record and replay tool, right? So that way there are a lot of record and replay tool anyway available in the market. The Selenium provides support for different programming language, Java, Python, C#, Ruby, PHP, and so on. You can write your test scripts in any language you prefer or you like. And again, as I said, one need not really know in-depth or advanced knowledge of these languages. You would still be able to write the Selenium scripts with a basic knowledge of this programming language. And also Selenium supports various operating systems. You can run Selenium test on Windows, Mac, or Linux, or even say if you have a Ubuntu machine, you can always run your Selenium test on Ubuntu machines. So you can run the test on any platform of your choice. Okay, so let's go now a little more deeper into Selenium. So I said that Selenium is not a single tool, but it is a suite of tools, right? So now let's look at what are those major components which comprises of the Selenium suite. First one is the Selenium IDE. So Selenium IDE is the most simplest tool in the whole suite of the Selenium. It is nothing but it's an integrated development environment. Earlier, this IDE was simply a Firefox extension and it offered a record and playback functionality. It was a very simple and easy to use. And as I said, mainly this is used for prototyping or for only the demo purposes, right? And not creating automation for your real-time projects because of its own limitation of being a simple record and replay tool. However, Selenium, what happened? Selenium IDE, it died with Firefox 55. So that means the support for IDE was stopped from Firefox 55 version. But the good news is very recently brand new Selenium IDE has been launched. And also what they have done is they have made this cross browser. That means you can install the extension on Chrome, the IDE extension on Chrome, or as an add-on on Firefox. So it is supported on both the browsers, Firefox and Chrome. Alright, so while we are talking of this IDE, let me also show you how the latest IDE on the Chrome looks. Okay, for that, let me go and launch my Chrome browser. So let me just open a new tab, and what I'll do is I'll search for Selenium IDE for Chrome download. Then I go to this website, and then you can see here Selenium IDE offered by seleniumhq.org. So what I simply need to do is, like you install any extension on your Chrome browsers, I just say add to Chrome, and this adds this extension on your Chrome browser. Now it has added. So Selenium IDE has been added to Chrome. Use this extension by clicking this icon. So can you see this icon here, which is Selenium IDE? That's it. So once you have installed this, you are free to start using the IDE on this Chrome browser. Similarly, you can do adding of this add-on, which is called as add-on on Firefox. So go to the Firefox browser, search for the Selenium IDE and just install that add-on. So let's get back to our presentation. So that's about the IDE. So what's our next component? Our next component is Selenium RC, which is nothing but Selenium Remote Control. Selenium RC is used to write web application tests in different programming languages. It interacts with the browser with the help of RC server. It has an RC server through which only it can interact with the web browsers. And how does it communicate? It uses a simple HTTP GET and POST request. And this is what was called as Selenium 1.0 version. But it got deprecated in 2.0 version and it was completely removed in 3.0 and was replaced with something called as WebDriver. So we will be talking in detail about why this happened, what were the drawbacks of RC which led to replacing with the WebDriver. So now that brings us to the third component, which is the Selenium WebDriver. This is the most important component. It is just a programming interface to create and execute our test cases. Of course, it's a successor of RC because there were certain drawbacks which I just mentioned, and we will be going in detail of what it were. So WebDriver, what the major difference what we see with the WebDriver is the architecture of the WebDriver is much simpler than RC for the reason that WebDriver interacts with the browser directly, unlike your RC where it needs an RC server to interact with the browser. So this gave a lot of advantage and edge over the RC. The fourth component, Selenium Grid. Selenium Grid is used to run multiple test scripts on multiple machines at the same time. With Selenium driver, you can only do the sequential execution. However, in real-time environment, you know that there is always a need to run tests on distributed environment. For example, say you have a web application and say you have automated around hundreds or thousands of test cases and you need to run them as a regression suite. And also one of the asks is that you need to run this on multiple browsers and multiple OS. Why? Since you have automated them and your application supports multiple browsers and OS. Now imagine the time taken to run these 1,000 test cases sequentially with the WebDriver, right? It's going to take quite a bit of time. So what you need is to run this parallel on multiple machines, matrixed across the browsers and operating system. And that is where the grid helps you in achieving that. So grid has this hub and node concept and it helps in achieving the parallel execution which I just talked about. So you can check out our detailed video on Selenium Grid on Simplilearn. Alright, so now we talked about the components of the Selenium. So let's look at the different versions it evolved into. So when I talked about RC, I mentioned that this was Selenium 1 version. So now let's understand how this evolved over years and what it offers today. So when Jason Huggins introduced Selenium, the tool was called JavaScript program. He called it as JavaScript test runner. It had one major issue. Now that is something called as same origin policy. So what is the same origin policy? It says that a JavaScript when executed in a domain can access web pages in that domain only, and it cannot access any web pages in another domain. I will repeat it. Same origin policies dictates that a JavaScript is executed in a domain can access web pages in that domain only, and it cannot access web pages in another domain. For example, say every web page in say google.com domain like search, email, drive can be accessible, but nothing outside of google.com, like say if you want to access a web page in say Amazon or Yahoo, is possible to access. Why? Because of the simple reason, which is a security reasons. Now, to overcome this, Paul Homan created something called a Selenium remote control server. And why did he create that? He wanted to trick the browser in believing that the Selenium core through which you're going to run your scripts and your web application under test are in the same domain, with which you are able to run your test on your web application without having to get into this issue of same origin policy. So this is what was a version 1 of Selenium, and we called it as Selenium remote control. And then what happened in 2007, Simon Stewart, he invented this WebDriver. Now why did he invent this? Because the architecture of Selenium RC was little complicated. RC required a separate server to talk to your browsers. So what he did was he removed the requirement of having a separate server in the RC, and this was the Selenium 2 version. Now, since it was a transition phase, both the Selenium RC and the WebDriver coexisted in Selenium 2, while the WebDriver was still under development. And then what happened in 3.0 Selenium is the Selenium core, which is the RC, was completely deprecated and only the WebDriver was made available. So in this series of videos, we will be working with Selenium 3.0. And now Selenium 4 is already around the corner. So alpha is already released as of the day when this video was made, and I believe some of the features what the Selenium 4 is going to offer is they are moving towards W3C WebDriver standardization 1, and also there is going to be an improved IDE, the IDE which I just talked about, that it's a improved version of the previous IDE, and then an improved version of Selenium Grid also. So they might be doing a GUI based grid, right? So these are some of the major features expected in this version. Why Selenium WebDriver? So let's look at what led to replacement of Selenium RC with this WebDriver. For that, first we need to understand the Selenium RC and its shortcoming. As I said, Selenium RC is a simple tool to write tests for web applications in various supported programming languages like Java, Python, Ruby, and C#. And this is the architecture of the Selenium RC at a very high level. First, you need to write test scripts in any of the supported languages of your choice. So if you're more familiar with Java, you would be writing your test scripts, all your commands in the Java language. So before we start writing the test, one of the major required for the RC to run is your RC server. So first you need to start this RC server before you run even a single line of code. And this RC server is a separate application. And now what is the function of this RC server? This Selenium server or the RC server is responsible for receiving Selenium commands from your test script. It interprets them and then reports the result back to your Selenium test script. Now what are the Selenium commands? These commands are nothing but the commands written in your test script. These are called as Selenium commands. That is what the Selenium server does. Now after the Selenium server's function, let's look at how the browser interaction happens. The browser interaction happens through this RC server. This RC server uses a simple HTTP post and get request to communicate. And how does this communication happen? This RC server acts like a proxy. Say for example, your test scripts asks for launching a browser. This command from your test script goes to the server, and then this RC server launches the browser, injects its JavaScripts into the browser. Once this is done, all the subsequent calls, that is all the subsequent calls is all the rest of the commands which you have written after launching the browser, go to this RC server and then to the actual web server. So it routes, all the commands are getting routed through your RC server to your web browser. Upon receiving this instruction, so what does the code do? It executes these commands as the JavaScript commands on your browser. So once these are executed, the response from the browser or the results what you say are sent back to the RC server, and RC server is responsible for sending it back to your test script, and then the test results are displayed here. Now if you see this complete cycle from starting your command from your test script, talking to the RC server, then RC server talks to the web browser, it injects the JavaScript here, runs your command, takes back the results, sends it to RC server, and then back to this test script. This whole cycle gets repeated for every command which is written in your test script. And this is how your test case gets executed. All right. So now everything is fine. So great. We are enabled to run the scripts. We are able to launch the browser. We are able to execute all the commands. So what was the problem here? Why was still RC not good enough? For the reason why the RC was still not good enough was, one, the architecture of RC is very complicated because of that intermediate RC server to communicate with the browser. So there is no direct interaction with the browser. This RC server needs to be installed before running any test scripts. That means it has an additional setup, because that is RC server is a mediator between your Selenium commands and your browser. The execution of the commands takes very long time. It is very slow. Why? Because we saw that every command written in your test scripts needs to make a full trip from your test script to the RC server, to the core, to the browser, and then back, which makes your overall automation test execution very, very slow. So how does Selenium WebDriver now overcomes this? This is a simple architecture of Selenium WebDriver. Even in WebDriver, we have test scripts. We have a web browser and a web server. However, we do not have an additional server for communication like the RC server, which we saw in the Selenium RC. This makes the architecture of WebDriver very simple. The Selenium WebDriver, that's one of the biggest advantages. The Selenium WebDriver does not use an additional server. Then secondly, it makes direct calls to your browser using your browser's native support automation. So since there is no intermediate server there, the browser is controlled directly from the operating system level itself. Now, due to this direct communication, the trips what we saw from the RC server to the browser and from the browser back to the RC server and to the test scripts, right? This was an indirect communication. Since this whole thing was avoided, the speed of test execution is much faster in RC. And this overall architecture of the WebDriver, if you see, is much, much simpler than what the RC provides. So this was the major drawback from the RC, and this is where WebDriver replaced RC. Now, was that all because of the architecture? No, there were few other shortcomings with the RC. APIs in Selenium RC. A single function has several commands. Redundant and confusing APIs. RC is less object-oriented API. Though there are good set of APIs to work with, they are pretty redundant and confusing. For example, how and when to use a type key or a type command. Another example is the mouse commands. Click or to use click at, or when to use mouse at or mouse down. So this was getting pretty confusing for the developers. And to top it all this, every browser interprets the command differently, which makes your test cases brittle when it has to work on the multiple browsers. Developers had a tough time making their scripts cross-browser, and they had to add browser-specific code. Whereas Selenium driver comes with a set of more matured and simpler APIs which are pretty straightforward to use. For example, a simple click to simulate a click action on any web element. Send keys, which simply means send the text to any web element on your web page. Scroll up or down on the web page, and so on. So we will see more of this commands when we actually start working with the WebDriver. Another difference is the browser support. Though both RC and WebDriver supports multiple browsers, RC does not have support for HTML unit, which is a headless browser, whereas the WebDriver supports testing on headless browser. Now, what is this headless browser? Headless browser is a browser which does not have a UI. It makes testing much faster because it does not need a real browser for testing. Now, to summarize all this, so if you look at the RC and the WebDriver comparison, which we talked about, RC is a complex architecture, whereas WebDriver has a simple architecture, for the main reason that WebDriver removed the need of having an intermediate server. RC, the execution of your test cases or your automation scripts, it's much slower than the WebDriver. RC requires a RC server to interact with the browser, whereas the Selenium WebDriver interacts with the browser directly using the WebDrivers. Also, we saw the APIs which RC provides, which are pretty confusing, and WebDrivers, we have much easier and easy to use APIs. No support for HTML unit browser, which is a headless browser. Selenium driver also provides support for HTML unit browser. Now that we have understood what Selenium RC is and why WebDriver replaced RC, let's go another level deeper into WebDriver. So what is Selenium WebDriver? We know that the WebDriver in its simplest term is a tool or a programming interface to create and execute test cases on a web application. It supports multiple browsers, i.e. Firefox, Chrome, Opera, Safari, Edge, and it also has support for headless browser. So we will know in some time what is a headless browser. Some of the features of WebDriver. So while RC was introduced in 2004, WebDriver got introduced by Simon Stewart in 2006. WebDriver can run on any platform of your choice, Linux, Windows, Mac, and even if you have a Ubuntu machine, you can run your Selenium WebDriver. And what is this actual WebDriver? Is it an IDE? No, it is a simply a programming interface to run your test cases. And how does it work? The test cases are created and executed using web elements or the objects using web locators and WebDriver methods. So once we get into the demo, or once you start understanding how Selenium works, you will understand what are these WebDriver methods and the locating techniques which are used to perform these actions on web element. Selenium WebDriver is pretty fast. Why? Since the WebDriver interacts directly with the browser and does not have an intermediate server like RC. Each browser with which you want to work with has its own driver on which your application runs. And this driver is responsible to make the browser understand the command which are being passed from your script, like a click of button or entering some text in any of the input fields. Through your scripts, you tell which browser you want to work with. Say you want to do all these actions, say on the Chrome browser. If you want to work with Chrome browser, then the Chrome driver is responsible for interpreting your instructions from your test case and executing them on the web application which is launched on Chrome browser only. So like RC, WebDriver also supports multi-programming languages in which you can write your test scripts, like the ones which are listed here. Also, WebDriver supports different frameworks like TestNG, JUnit and NUnit. When we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. Now let's try to know what is the architecture of Selenium WebDriver. WebDriver has 4 different components in it. One, we have the client libraries, or what is also called as language binding. Since I said Selenium supports multiple languages and you're free to use any of the supported languages to create your automation script, there are libraries available on Selenium website which you need to download and use them. Let me show you that. So let's go to my Chrome browser. So I have the Selenium HQ website already launched here. So guys, if you're working on Selenium, this website seleniumhq.org is going to be Bible. So everything and whatever you need to know and work with Selenium is available here. For now, we want to see the client libraries or the language binding. So for that, what you need to do is, if you go to the download section here, can you see here the Selenium client and WebDriver language binding? So for each of the languages which is supported, you have a client library which you can download from here. So if you're working on Java, you need to download the Java libraries. If you're working on Python, you need to download the Python libraries, right? So these are called as language bindings. So Selenium provides a lot of APIs for us to interact with the browsers. And when we do the demo, I will be showing some of those APIs. Now, what are these APIs? These APIs are the REST APIs. REST is representational stateful APIs, and everything for Selenium happens through this REST calls. The second component is the JSON wire protocol. So what is JSON? JavaScript object notation, and it's a standard for exchanging data over the web. So for example, you want to launch a web application through your script. So what Selenium does is it creates a JSON payload and posts the request to the browser driver, right? And where are these browser drivers? These are here. Right? And what are these browser drivers? These are a driver specific to each browser. So if you see here, you can see drivers for Chrome, Firefox, Opera, Safari and Edge, right? So we interact with the actual browsers here using these drivers. And how does this happen? This driver establishes connection with the real browser without revealing the internal logic of browser functionality, right? That's exactly the function of this browser driver. Now, what does that mean? Let's say we want to execute a test script. So what happens when the script is executed is an HTTP request is generated and sent to browser driver for each command in the script. And then the driver receives the request through this HTTP server and does all the execution on the actual browser. Once the execution is done, the execution results are just sent back over the same HTTP server to your test scripts. So this is the simplest form of the architecture of the Selenium WebDriver. Well, now as every tool has its own advantages and its limitations, so let's look at what Selenium WebDriver limitations are. Cannot test mobile applications, requires framework like APM. Selenium is for automating web application. It cannot handle mobile. right? Mobile applications are different and they have its own set of automation tools. However, what Selenium provides is the support for integrating this APM tool. APM tool is one of the popular tools for mobile application automation, right? So it provides a support for integrating APM tool. So using APM and Selenium, you can still achieve mobile application automation. Now, when do you usually use this? In cases where, say, your application under test is also supported on mobile devices. So that means you need a mechanism to run your test cases on your web browser as well as your mobile browsers, right? And this is how you achieve it using Selenium. When we talked about components of Selenium, I said that a WebDriver can achieve only sequential execution. But in real time, we know that we just cannot live with this. We need to have a parallel execution on multiple machines and on multiple browsers. So this limitation of WebDriver is replaced by having the grid, which helps us in achieve the parallel execution. And do check out our video on more details on Selenium grid. Selenium WebDriver has limited reporting capability. It can help create basic reports, but definitely we need more, especially when we are working on a big project. We need good reports to be created. So what it does is we have a support for multiple tools like TestNG, ReportNG, and even the extent reports, which you can integrate with Selenium and generate beautiful reports. Isn't it really powerful? Alright, there's another challenge what we have. These are amongst few of the challenges what I have put across here. There are other challenges also, but always there is a workaround to get through those challenges. So another challenge which we have mentioned here is Selenium is not very good with image testing, especially designed for web application automation. But then we have other tools which can be used along with Selenium to achieve any kind of image testing you want to do, like AutoIt and Securely. So same way, the way it provides a mechanism to integrate APM, so Selenium also provides a way for integrating AutoIt and the Securely tools. So if you look at all this, Selenium still provides a complete solution for our automation need. And that's the beauty of Selenium that makes it most powerful tool today for automation. Okay, so let's look at WebDriver in action. So before we do that, let's understand some of the basic browser commands and functions that we will be using in our demo today. The GET commands. So there are 6 GET commands to perform various actions on the browser. Driver.get. This is used to launch any website application. It takes a string argument and this needs to be a fully formed URL which you want to launch. Driver.getTitle. So this method fetches the title of the web page which you're working with. So for example, let's go to eBay. So if you just hover your mouse here, can you see the text there? Electronics, cars, fashion, collectibles, coupons and more, eBay. So this is nothing but title of this current page. And this command helps us to get the title. Get current URL. So to get the URL of any page is when you want to use this command. So this will be used especially when you're working with multiple web pages and you want to say print whatever the current URL you're working on the console. Get page source. This method dumps the complete HTML page source on your console. Actually, this is not really much used unless you really need to look at anything in your HTML pages. And then there are 2 more GET commands related to Windows handles. These are used for handling multiple tabs and multiple windows on the browser. Now, we will not be dealing with this in today's demo. However, if you want to know the details of this command, these are available in our video tutorials for these commands. The next set of commands are the navigational commands. So these are self-explanatory and basically are used to navigate between the multiple pages of your web application. The first one, the driver.navigate.to, is very similar to driver.get. So both does the same function. And then you have navigate.back, navigate.forward and navigate.refresh. So this is used for refreshing your browser page. And then there are 2 commands, browser commands, which we use. One is the driver.close. So this closes the current browser window. So if you have got multiple tabs open in the window and you want to close a particular tab, so that is when you use driver.close. And driver.quit, what it does, it quits the entire browser session. Then there are few other commands. And some of the commands are listed here. However, if you see, there's a huge list of commands available in Selenium. And since we'll be using just a few of them in today's demo, I have listed here. So let's just understand these very basic commands which we will be using. Driver.findElement. Now, when you want to work with any application, what is that you need to do? You need to perform actions on the elements of the web page. And these are called as web elements. For example, let's go to our ebay.in. So on this website, say you want to search for JBL speakers. And what do you do when you want to search for this? You would identify the search box and you will enter the text JBL speakers, right? And then you go ahead and click on the search button. So this is the set of operations which you will do. Now for us to write this, and this is exactly what you need to do through your commands. For us to really write this text as JBL speakers, I need to know what this particular element is. Okay, so this particular input box is my web element, which I need to identify. Similarly, if I want to click on the search button, I need to identify what this button is. And that's exactly is done by using driver.findElement. Selenium has multiple ways of finding these elements. It has 8 element locating techniques. And our future videos on Selenium do cover these 8 element locating techniques very much in detail. So for us, right now we'll be using couple of them. So one is with ID and one is with a link text. The next one, the send keys. So as the name indicates, it is used to send a certain text to any web element you have identified or you want to work with. Like in this example, as I said, since we want to search for JBL speakers, right? I would be basically sending the text JBL speakers to this web element using send keys. Click. So after entering the text, what we need to do, I said, we need to click on the search button. So for all such actions, we have methods defined in Selenium. And one of them is this click. What this does is it just clicks on the web element or the button which we want to work with. So now with these basic commands, let's go ahead and start writing our code for our test case. So what is the test case we are going to write today? So this is my use case today. So use case 1, as a user, I want to log into eBay application, search for JBL speakers, and then I want to check the today's deal. So there is something called as the day's deal. We will go and click on that and see what are the deals available. I have another use case here. What says is, from this website, from wherever we are, right, navigate to the Simplilearn website and navigate back to the ebay.in. So this, using this use case 2, what I want to show you is how do we use the navigational commands. And my third use case is, from the ebay.in, I want to print the page title and close the browser. So with this, we are trying to demonstrate at least few commands from each of the categories which we talked about. So I will be using Eclipse for writing our test scripts. And if you want to know how to get started with Selenium, how do we install Selenium, you can refer to our videos on installation of Selenium by Simplilearn. Okay, let me go to my Eclipse. So in Eclipse, what I have done is I have already created a project called Selenium Demo. And in this project, I've gone ahead and created a Java class in which we would be writing our test case. So the Java class which I have created is ebaysearch.java. And also what I have done is, if you look at few import statements here, I have imported all the required Selenium jars here. So if you look here in the referenced libraries, the way after we work with Java here, right? So Java is the prereq for your Eclipse. So you already have the Java libraries available here. So what I need to do is I also need to import the Selenium jar files, and this is the list of Selenium jar files which you will need to work with the Selenium, and this I've already imported for you. Then another thing what I do as following a best practice is, instead of writing all my code under this main function here, what I do is I create methods for each of the use case or the test case which I'm writing. So same thing, I'm going to do that today for all the use cases which we have taken for this demo. Now let's get started. So what is the first thing which we need to do? The first thing what we need to do is you need to declare your WebDriver. So which I've already done here. I've said WebDriver driver. And then I need to launch the browser before even I go into ebay.in and start performing the other testing. Now for me to launch browser, this is one method which I've already written here. So let me walk you through this. So there are multiple steps we need to follow for launching the browser. The first thing is set system property. So let's understand this particular command here, the one which I have highlighted. So this is used to set the property for your Gecko driver. Now what is a Gecko driver? If you remember, while we are talking of WebDriver architecture, I said for whichever browser you want to work with, you need to tell the WebDriver as which browser is what you're going to test with. And in my case here, I'm going to be using Firefox browser. And also if you remember, while explaining the architecture, I said every browser has its own driver which you need to download and install. And where is this driver? Let's go ahead and see that on the seleniumhq.org. So let me go to my Chrome browser. I already have a seleniumhq.org website open here. Now on this website, in the download section, if you go down, you can see something called as third-party drivers, binding and plugins. And here you would see a list of all browsers, Gecko driver, Chrome, Opera, Edge, right, and HTML unit, which is headless browser. So all these browsers which Selenium supports listed, and for each of this browser we have a driver associated with it which we can download. So if I want a Gecko driver, what I need to do is I need to click on this latest link. This will take me to the latest web driver which is available. So depending on the operating system which you're using, right now I'm using a Mac, so I've already downloaded it. So once you download, you need to place it in a particular directory. Okay, so let's go back to this. And now if you see this path here, what I'm highlighting, this is where I have kept my Gecko driver. So this Gecko driver, what you see is my executable. So if you're using a Windows machine, it will be gecko driver.exe. So this is the driver which we'll be working with. Now coming back to the system.set property. This particular method or this particular command is used to set your driver property. It is a key value pair, and you will need to know which keys depending on which browsers you're working with. Since I'm working on the Firefox browser, the key which I need to set is the web driver gecko.driver. If I'm using Chrome, what I simply do is I have a key called Chrome, and then I would set this path to Chrome driver, and this is exactly you need to do. So for you to, even before launch the browser, you need to do this set property. So let me change this back to Gecko. So now we are clear till here. Now what is the next command which we need to, after setting the property, is after setting the property you have to instantiate the web driver, which is done by using this particular command, driver is equal to new Firefox driver. So once you do this, your browser is going to get launched. Then once your browser is launched, what is the next step you do? You would be launching the application on which you want to perform your test, and that is done by using the command which we just saw now, driver.get. Now since I'm going to be working with ebay.in, I have just said driver.get and the URL, fully formed URL. So this particular method is going to help me launch the Firefox browser and also launch the eBay application. Now advantage of using methods like this is you can reuse these methods in every test case which you're going to write, or you can make a common function of this and just call this function in any of your test cases. Now for me to call this method, what am I going to do? I'm going to create an object of this class. Let's do that. Object is equal to new, done, and then I need to call this method obj.launch browser. Good so far? Alright. So now let's get to the first use case. So let's go back to our presentation and see what was our first use case. Our first use case was that we want to launch the eBay application, which we have already done in the launch browser method, and then we want to search for JBL speakers. Now for that, what we will do, let me create a method here. So I will call this method, I'll say public void, say search product. That's my method name. So I have created a method called search product. Now what I need to do is I need to search for JBL speakers. So for that, let me go to my Firefox browser, and I need to first identify the search box element. So for identifying, what I do, I go to this website, I go to this element, and then I say inspect element. So now I know that there is already an ID which is unique to this particular web element available. So I'm going to make use of this ID. I need to go to my Eclipse. So now here I'm going to use the find element method. So for that, I'll say driver.findElement, I'll say by.id, and it's a string argument. I'll just copy the ID which I copied from the Firefox browser. And then what is the operation I need to do here? I need to send keys. And what is the keys I need to send? The product which I'm searching for. I'm searching for, say, JBL speakers. Done. So with this command, what it will do is it will enter the text JBL speakers in the search box. After doing this, I need to click on the search button. Now similarly, I need to identify what is the web element search. For this, again, I already have a unique ID here, which I'm just going to simply copy from here and use it in the find elements. So same thing I will do, driver.findElement by.id, and this is the ID of the button, and here what is my operation? I need to click. Done. Good so far. Now other thing what we also need to understand here is, so what happens sometimes depending on the websites, some websites are pretty slow even while loading the page, and some are pretty fast. Now for the Selenium to work without having to fail or without having to create exception of not finding the elements, it is good to use certain waits. So why we need to use waits is, say for example, when after entering the JBL speakers and after clicking the button, it's going to take a while for it to search for JBL speakers and give us that web page with the list of JBL speakers. And even before we start doing the first command, like searching, once we load the page, it takes time for the complete page to get loaded. Okay, so Selenium provides a lot of synchronization commands, right? And it's a very big topic on its own. which needs to be used especially when you're working with any kind of website. Okay, so there is since it's a separate topic, there's a separate video which will help you understand how to use the synchronization. Now, for the demo purpose, we have certain wait commands which can be used, and that is exactly which I'm going to use here. So that is called as thread.sleep. So what this does is, say I'm going to give 2000 here. What this does is, this script waits for 2 seconds, right, after the previous command is executed, and then it executes your next command, which is our find element. Now this is showing us an exception because it wants us to add a exception here, add throws declaration, which is interrupted exception. Okay, we need to do this. So once we are done, okay, we have done the click. So let's see what is the first use case which we had. Have we covered everything in the first use case? Okay, we said log into eBay, done, search for JBL speakers, and then I want to check on the days deal. Okay, we need to do this also. So for that, again, what we need to do is we need to go and identify. So what I will do, I'll use the inspector here and look for this daily deals. Now this is a link text, it's an anchor tag. So what I will do, I'll copy this link text, daily deals. I'll go to my Eclipse. Now after this, I will give another thread.sleep of say 2 seconds. That should be more than enough. And then I'll say driver.find element. Now this time I will be using something called as link text. And here as an argument, as a parameter, I'm going to paste the daily deals which I just copied. And then what do I need to do on this web element? I just need to do a click operation. Done. So the complete first use case we have covered. So what we will do is, let's go ahead and execute this first use case. Now I have launched the browser here. I also need to call this method, which is search product. Now again here, since we are doing that add throw declaration on the method, we also need to do it for the main function. Exception added. I'll save this, and for me to run this, what I do is I simply right click on that and I say run as Java application. Now we see that our Firefox browser is launched, the eBay application is also launched, and JBL speakers entered and search clicked. So we have a list of JBL speakers here. And now as per our test case, it has to go on the daily deals, which it just did. Great. Alright, so we have our first use case working. So right now I have not used the browser.close. So what I will do is I'll just manually go and close this browser. So we are done with our first use case. Now let's move to our second use case. So what second use case says is, from wherever you are, right now we are on the ebay.in, navigate to Simplilearn website and then navigate back to ebay.in. So let's see how to handle that. So let's go back to my Eclipse here. Now let's create another method. Instead of saying test case 2 or use case 2, we'll give a more meaningful name. I'll say navigate, since we are exercising the navigate commands here. I'll just use this method. Now, so we have done the click. So I need a quick thread.sleep here because I want it to wait so that we can see. Otherwise, it's going to be so fast, we will not be able to see what are the operations it did. So I'll just add a thread.sleep before we start navigating to the new website. Okay, thread.sleep, and I guess 2 seconds should be good enough even here. So same thing, we need to add the exception. So add throws declaration and interrupted exception. All right, done. So now what we need to do is we need to navigate to the simplilearn.com. So for that, first I need a fully formed URL of the website which I want to launch. Okay, so let me go to, and here instead of ebay.in, I would say let's search for Simplilearn. I have it here, and I just pick this from here, https www.simplilearn.com. So let me go to my Eclipse, and here we saw another command like get. We said navigate.to. So let's use the same command. So I'll say driver.navigate.to, and I'm going to use to URL because, or you can just use a string because this is going to be a string variable. Now what does this command do? This will simply navigate to the URL which we have specified here. Now here again I'm going to give a quick sleep here so that we are able to see the website before we navigate back to the ebay.in. So I'll use a thread.sleep. This time probably I'll give a 3 second wait. Then what does our use case say? Let's go back to use case once and check. And it says and navigate back to ebay.in. So that means I need to use a driver.navigate. Can you see the list of commands here which provide, which the navigate class provides? Okay, and the back is what we need to use so that it comes back to the ebay.in. Done. So far so good. Now let's do one thing before even we go to the use case 3. Let's execute our test case till here. So what I'll do, I'll save this program, and after search product I will call navigate method. Okay, I will save this and then right click, run as Java application. So our Firefox is getting launched. It has launched. The eBay application is on. So it's going to first find the JBL speakers. Click on the search. We have a list of JBL speakers. Then it will click on the daily deals. Yes, it is doing that. We got the deals of the day. Yes, it is now navigating to simplylearn.com. Now after 3 seconds, it should take me back to the ebay.in. Okay, cool. So this was the last page where we left before we navigated to Simplylearn, right? And that is where we have come back using the back command. So now let me close this again because I have still not incorporated the driver.close. Now let's look at the use case 3. Now use case 3 says once you're back to ebay.in, print the page title and then close the browser. Cool, very simple. So we'll go back to Eclipse. Probably in the same method, what I can do is, once I'm back here, I will say, so I have to use driver.getTitle. That was a spelling mistake, driver.getTitle. Okay, this is the method which we are going to use to get the title of the page. Now, we also said that once we get the page title, we want to print it on the console. Now, how do you print it on console? You just use a sysout statement. So, instead of just writing this, what I will do is I'll directly write a sysout statement, system.out.println, and I'll write a text as the title of this page is, and then we will concatenate with driver.getTitle. As simple as that. And after I do this, I will simply call, it's actually, I want to call the driver.list, but it's always good to create a separate method. So I'll say public void close browser method. And here I'll simply say driver.quit. You can use close or you can use quit. So let me demonstrate how do we use quit here. Now I need to call the close browser. So simply what I'll do, I'll say obj.close browser method. Okay, so this completes our all 3 use cases. So now let's execute all these 3 use cases now. And we should be able to see the title of this page on the console. So same thing, what I do is right click, run as Java application. Okay, same thing, our eBay is launched now. Send keys the JBL speakers, click on search button, executed, and then it has to click on the daily deals. That it is done. Moves to Simplylearn website. Now it has to come back to ebay.in and we should be able to see the close browser, which just happened at the snap of the finger, right? So now for us to know whether it really happened, what we have done is we have printed the page title. Okay, now can you see here? We have the complete page title printed here. All right. Selenium installation is a 3-step process, so it has certain prereqs. The first prereq is you need to have Java on your system. So we will be installing Java first, and then we will be working with Eclipse IDE. So we will be installing Eclipse, and then we will install Selenium. For Java, we will install the version Java 8. And for Eclipse, we have a version 4.10. This was the last stable version which was released in December last year. So I'll be using that version. And Selenium, we will download the latest 3.14 version. Okay, so let's get started with our first step, which is the Java installation. So to install Java, let's go to the browser and simply just search for Java 8 download. So now you will see that there is an Oracle site which is listed there, and that is where you would be downloading all your Java package. So go ahead and click on that. And for you to download any JDK package from the Oracle site, you need to create an account. So if you already have one, you just need to log in using that account and then you can download any of the JDKs. And if you do not have one, please go ahead, create a new account on the Oracle, log into that account, and then you can just download the Java 8. So since I already have an account and I have already downloaded the package, but I'll show you how and where to download it from. So in this page, if you scroll down, so you will see this Java Development Kit 8211. So this is the version we'll be downloading it. So click on the Accept License Agreement, and then since we are working on the Windows system today, so we will be downloading this, the Windows package. So just click on that and it will get downloaded in your downloaded folder. And as I said, I've already downloaded the packages. So here it is. What I've done is I've just created a directory called installers, and I'm going to be keeping all my installables here. So here I have a folder called Java installer, and this is where my installable is. So now that we have this file, so we will just go ahead, double click on it and launch this installer. The installer is launched and just click on run. So this will take a few minutes to install Java. The installer is launched. Now just click on the next button here. So here for the installation directory, you can change the directory to the choice of whatever drive and the folder structure you want to. I would like to leave it as default here, and we'll just go and click on next, and then the Java installation is in progress. So let's wait until this is completed. It really shouldn't take too much time, maybe just a few more minutes here. Okay, accept the license term. Just click on next. We'll leave the destination folder as it is. So JDK 8 is successfully installed on your system. So close the installer now. And let's go ahead and check whether the installation is done properly. So for that, what I'll do is I'll go to my command prompt and I'll just say Java minus version. So it says Java version 1.8 and this tells us that the Java is installed successfully. Now, after this installation, there are a couple of configurations which we need to do. And what are those configurations? One is you need to set the path variable, and then we are also going to set a Java home directory. So for that, first let's go ahead and check where is the Java installed actually. Let's figure out the directory first. So if you remember, the directory structure where the Java got installed was in program files, Java. There are certain previous versions which I had installed and then uninstalled it. So that is why you see some residuals here sitting here. Let's not worry too much about that. Instead, let me go to the latest one what I have installed, which is this. Okay, and there is a bin folder here. And this is the path which we need to set in our path variable. So what I will do is I'll just copy this path and then go to your control panel. Here, go to your, where is my system? Yeah, so click on the system, go to advanced system setting. And here in the environment variables, find the path variable, okay, and then say edit. Now, what are we doing here in the path variable is we are going to add the Java bin directory to the path. Be very careful whenever you are editing your path variable. Do not overwrite anything. Always go into the edit mode, go towards the end here, and then just say Ctrl V, paste the path which you have just copied from the Explorer window. That's it. Now just say OK, done. So your path setting is done. So what's the next one we need to do? We need to add a new environment variable called the Java home. Now what I'll do for that is I'll just say new. I'll just type Java home here. And what is the value of this we need to set? We need to set the same path but without the bin directory. So we just need to set the path till your Java directory. That is this. So we'll just copy the path again and paste it here. That is all. Just say OK, click on OK here, and we are done. So again, let's go to our command prompt and just say Java minus version. So everything seems to be fine. So now successfully we have installed Java on the system. So what is our next installation step what we have? Now we need to install the Eclipse. So let's go back to the browser again. So to download Eclipse, we will be downloading the package from the eclipse.org. So when you go here to eclipse.org, you can see the latest version which is available. And the latest version available when this video was made was 2019-06. So especially with Eclipse, since it's an open source, I prefer to work with the last stable version, and so does most of the developers too. And hence that is the reason why I have picked up the version which is like last year's version, which is 4.10, which was released in last December. So you can always choose to go with the latest version, but then if there are any issues and if you're like first time working with the Eclipse, you're going to get confused as where these issues are coming from, right? So I would still recommend that you use the last stable version which is available with your Eclipse. So now to get the last stable version, what you need to do is go and click on this download packages. And here, if you scroll down this page, you can see here more downloads. So there is a list of all the previous releases of Eclipse which is available, and this is what we need to download. So just click on that 4.10 version and then click on the OS on which you want to install Eclipse. For us it is Windows, so I'll just click here on the 64-bit Windows and then click on the download and you will be downloading the complete package. So once you download, this is what it will look like. So let's go back to our directory of installers. So this is the installer for the Eclipse which I got. Now what's the next step I need to do? Just launch this installer and install Eclipse. So I'll just say double click on this. I'll say run. So here you'll see multiple options here for Eclipse installation. So depending on your requirement, you can go ahead and install any of these packages. So for us, we just need an Eclipse ID for Java developers. So I'll select this and I'll say install. So again, you'll have a choice of directory where you want to install. So I have chosen D drive here. This is the default directory name it takes, which is okay. We can leave it as it is. And then also you have an option to create a start menu entry and desktop shortcut. So just leave the default selection as it is and go ahead and click on install. So this will take a while to install the Eclipse. This says select all. You can close this window. This says select all and accept it. Okay, so the installation has been completed successfully. So let's go and click on this launch and let's see the first window what opens. When you launch the Eclipse, you need to specify a workspace directory here. Now what is this workspace directory? So this is a directory or a folder wherein all the Java files or any programs or any artifacts which you're going to create through Eclipse will be stored in this particular folder. So this could be any location on your system. So this is, you can go ahead, browse the location and change it. So for in our case, what we will do is I'll go to the D drive and I already have a directory. So here I'll just select this folder and then create a folder called workspace. I'll say my workspace and then I'll say launch. So every time I open the Eclipse, right? So this is going to take as my default workspace, and all my programs, all my Java scripts or my automation scripts are going to be stored in this particular location. So we'll say launch. So this is a welcome window which opens. We can just close this and there we go. The Eclipse is open with a certain perspective. So there are certain windows here which we do not need. Let's just close them. So now the first thing what you do after launching the Eclipse is go ahead and create a new project. So I'll say file, new, and since I'm going to be using Java with Selenium, I'll say create Java project. So give a project name. Let's say my first project. Now you have an option here to select the JRE which you want to use. So we just installed this JDK 1.8. Okay, so I'm going to click on use default JRE. Otherwise, you also have an option to use a project specific JRE. For example, I could have two different projects where one project I'm going to be working with JRE 1.8 and there is another project which I want to work with the latest Java, maybe Java 12. And I can have more than one Java installed on the machine. So this gives me an option to select whichever Java I want to work with. So if you have another Java installed here, it will show up in this list. So and you can just go ahead and select that. Now since we have only one Java installed on our machine, which is Java 1.8, I will say use default JRE, which is 1.8, and I will click on finish. Now if you observe this folder structure, the project which is created, see all the reference libraries to this particular Java have been created here. Now we are ready to create any kind of Java programs in this project. So now we have successfully done the second step of our installation, which is the Eclipse installation. After this, we need to install the Selenium. So again, let's go back to the browser and see what files we need to download to install Selenium. So let me go to my browser and here I will be going to the seleniumhq.org. So if you're working with Selenium, this particular website, the seleniumhq.org, is going to be a Bible. Everything and anything related to Selenium is available in this website. Whether you want to download the files, whether you want to refer to the documentation, anything regarding to Selenium is available here. So what we want now is the installables for Selenium. So here, go to the download tab. Now, for you to install Selenium and start working with Selenium, there are three things which are required for you to download. One is a standalone Selenium server. So this is not required immediately when you get started with Selenium. However, when you start working with remote Selenium WebDriver, you would be requiring this. When you have a grid setup, you will be requiring the standalone server. So for that, what you can do is you can just download the latest version available here. So when you click on that, it will download the file into your download folder. So this is one particular file which you need to keep. Next, Selenium client and WebDriver language bindings. Now in today's demo, we will be looking at Selenium with Java. So that means my client package of Java is what I need to download. So whatever programming language Selenium supports, we have respective downloadables available with that. Say if you're working with Python, then you need to download your client library for Python. And since we are working with Java, you need to download this package. So simply what you need to do, click on this link and it will download the Java package for you, which are basically the jar files. So we have client libraries now, and then there is another component what we need. Now with Selenium, you're going to be automating your web browser applications, correct? And you also want your applications to run on multiple browsers. So that means your scripts, the automation scripts which you create, should be able to run on any browser. Selenium works with multiple browsers like Edge, Safari, Chrome, Firefox, and other browsers. Even it has a support for headless browser. Now every browser which it supports comes with its own driver files. Now say for example, we want to say work with Firefox driver. So that means for us to start working with Firefox browser, we need to download something called as a Gecko driver here. And if you want to work with Chrome browser, you need to install the Chrome driver. So depending on what browsers you'll be testing with, go ahead, click on each of this link and download the latest driver files. Now, since we are going to be working with Firefox in this demo, what I need to do is I just need to click here on the latest link. So when I click on the latest link, it is going to take me to this driver files. So driver files are specific to each of the operating system. So if you go down here, you will see there is a separate driver file available for Linux, for Mac, and for Windows. So depending on which operating system where you'll be running your test, download that particular driver file. And this is the driver file I need because we are working on Windows machine. So these are the 3 different packages which we need to download from the seleniumhq.org for us to install Selenium. So let me show you the folder where I have already downloaded all this. So if you see here, Selenium Java 3.141.59. Okay, this is nothing but our client library which we saw here. Let's go back to the main page here. That is this. So once I download this, this is a zip file. After I unzip the file, this is the folder structure I see. And let's see what is there in this folder structure. So there are 2 jar files here, and then in the libs there are multiple jar files. And we will need all this to work with Selenium. And then we also downloaded the driver files. So what I did was, after downloading those driver files for the browser, I created a directory here called drivers, and I've kept all my browser drivers here. So I have a driver file downloaded for Chrome. I want to work with Firefox, so I have a Gecko driver here, and then for Internet Explorer. That's it. So this is all we need. So once we have all this, what you need to do is go to your Eclipse. In the Eclipse, right click on the project which you have created, and then go to the build path and say configure build path. Go to the libraries tab here. Now, do you see this JRE libraries here? This is what got installed first. And now similarly, we are going to add the Selenium jars to this library. And how do we add that? On your right, you can see this add external jars. Click on add external jars. Go to your folder where you have downloaded your Selenium, which is this. Select all the jar files which is available. So I have 2 jar files here. I'll just say click open. Again, I will click on add external jars. Now from the libs folder, I will select all this 5. So select all the 5 jars and click on open. So you should see all the 7 jar files here. So once you have this, just say apply and close. Now, if you look into your project directory here, you will see a folder called referenced library. And this is where you will see all the Selenium jars here. This is a very simple installation. In Eclipse, when you want to install Selenium, you just need to export all the jars of the Selenium into Eclipse. And now your system is ready to start working with Selenium scripts. Alright, so now let's just test our installation by writing a small Selenium test script. So for that, what I will do is, I'll go to the source folder, right click, new, and I'll say Java class. So let's name this as, say, first Selenium test, and I will select this public static void main, and I will click on finish. Alright, so now let's create a use case. Say we want to launch a Firefox browser, and then we want to launch the Amazon site. So these will be just 2 simple things which we will be doing in this test script. So for me to do that, what I usually do is I create a method for any functionality which I want to create here. So now I want to do a launch browser. So I'll create a method here called launch browser. Now, whenever you start writing your Selenium scripts, the first line what you need to do is you need to declare an object of WebDriver class. So here I'll say WebDriver driver. So now if you hover over this error, what it is showing, it says import WebDriver from org.openqa.selenium. So if you remember, when we installed the Selenium, we imported all these jars, right? So that means whenever we want to use a WebDriver, we need to import this class from these packages. So just go ahead and click on this import state. Done. Now next step. Now for us to launch a Firefox browser, it is a 2-steps process which is involved here. One is you need to set the system property, and then you need to launch the driver. So let's do that. I'll say system.setProperty. So use this method set property. So this takes 2 arguments, the key and the value pair. Now what is the key I'm going to mention here? I'm going to be mentioning the Gecko driver and the path for the Gecko driver. Okay, because since I'm working with the Firefox. So in double quotes, I'll say webdriver.gecko.driver. This is my key. And the value is going to be, the fully qualified path for your driver files. And you know where we have kept our driver files. Let's go to that. Driver files in D:, I have Selenium tutorial. In installers, I have driver folder. Okay, so I'm just going to copy the complete path from here. Control C, and I paste it here. Control V. Along with this, I need to provide the file name for the Gecko driver, which is geckodriver.exe. And let's complete this step. Next. So once I've set the property, I need to provide a command for launching my Firefox driver. And how do I do that? I simply use this driver object which I've created, driver equal to new Firefox driver. Again, similarly, the way we imported packages for WebDriver, we also need to import the package for Firefox driver. So just hover over the mouse over that and select import Firefox driver. With these two statements, we will be able to launch the Firefox browser. And as I said in our use case, what is the next thing we want to do? We want to launch, say, Amazon.in website. For that, there is a command in Selenium which says driver.get, and you pass the URL here. So for me to write the URL, what I usually do is I go to my browser, I open the website which I want to work with. In our case, it's Amazon.in, and I just simply copy this fully formed URL, go to my Eclipse and just paste it here. Now this ensures that I don't make any mistakes in typing out the URL. Let's complete this statement and we are done. And now in the main function, I'll just create an object of this and we will call this method. So I'll copy this class, first Selenium test, say obj equal to new first Selenium test. And now I'll say obj dot, this is our function, launch browser. So let's save this and execute this. Control C, right click, run as Java application. Okay, so the Mozilla Firefox has been launched. Now it should launch your Amazon.in. Bingo. So Selenium installation on Mac is a 3-step installation. One, we need to install Java, which is a prereq, and then we need an IDE to work with. So we will be installing Eclipse, and then we will install Selenium. And these are the versions of the installers which we are going to use. So we will be using Java 8, Eclipse version 4.10, which was released in 2018 December, and then Selenium version 3.14. So let's get started with our first step, which is the Java installation. So for us to install Java, let us go to our browser, and simply what I'll do is I'll just Google for Java 8 download. Okay, so we would select the Oracle site for downloading the SDE. Okay, so once you go here, you can see that we have something called as Java Software Development Kit 8U211. So this is the version we'll be working with. So in order for you to download, you need to have an Oracle account. So since I already have one, I have directly been logged into that. So if you do not have an Oracle account, please go ahead, create an account for yourself so that you can download any of the Java installers. Now let's go for and download our package. So I'll be downloading this package. For that, I need to click on Accept License Agreement. And then since we are going to be working on Mac, this is the package which I'm going to download. So let's go ahead and click on that. And now the download is going to start. However, we will not wait for the complete download to happen since I have already downloaded the package and I have kept it in one of my folders. So let me show you where that is. So let me go to my Finder. So what I have done is I have created a folder called installers, and all the software which we are going to require today for us to work with Selenium is what I have downloaded it and kept it here. So we'll go step by step so that you understand what each of these packages are. So as you see here, I have the JDK 8, which I've already downloaded. So let's go ahead and install JDK. So how do we install JDK? So you have the DMG file here. You just go ahead and double click on that. Okay, and then I'll double click on this package, and then we will say continue and install. So it's going to ask me for my password. Okay, I've given my password and I'll say install the software. Probably it will just take a couple of minutes to install Java. Okay, there you go. So now the Java has been installed. So let me close this window. Let me close this window too. And then now I'll go to my terminal window. So let's open my terminal. And here, let's say Java minus version. Bingo. So there we have Java 1.8 installed on our system. Now there are a couple of other things which you need to do. Apart from installation of your JDK, you also need to set some system variables, right? So in Mac, how do you set the system variables or the environment variables? You do that in your bash profile. So let's see how we do that. All right. So what I will do is I'll use an editor, which is my VI. Okay. And then I'll open my bash profile. So what is bash profile? It's a config file for your bash shell. This is mainly used to export variables in your shell. Like in Windows, we are going to do the system variable setting from the advanced setting, right? So similarly, we are going to do that here. So I'll say vi.bash_profile. So this is the file where I will be adding Java home path. Okay. Now I have other paths here already written because I'm working with other multiple software on this machines. And now I'll go to the end of this file and I'll say export Java home equal to. Now what is the path we need to give for Java home? We need to give the path where the Java has been installed on your system. Okay, first let's go and find out that path. So let's go back to our Finder, and then I have a folder called library here. So here there is a Java, and then there is something called as Java virtual machines. So if you have a single Java or multiple Java versions installed, so all those versions you're going to see under this directory, which is Java virtual machines. And Java 1. Is what we installed just now. So let me go and open that folder. There is something called as content and then home. And in this you have your JRE and bin folder. So that means I need to give my Java home path until here, till this home directory. So simply what I'm going to do is, I'll just go here, say get info, because I want to just copy the path. And what you can do is, you copy this path, okay, and then go back to your shell, and here I'm going to paste this path, plus I want it till the home directory. So I'm just going to type out HOME home. That is it. So you have now set your Java home environment variable. So simply you do save the file, escape:\wq and come out of it. And now what you need to do for this bash profile to be activated, you just exit out of this terminal. Okay, close this terminal window, and I'll go ahead and open another terminal. So let me close this info text. So here let me again give Java -version. Okay, so everything seems to be working fine. So this completes our Java installation. Now your system is ready and you have your Java up and running. Other thing which you also can do is go to your system preferences. Okay, here you will see this Java control panel. Okay, this is another way of finding out that your Java has been installed successfully on the machine. So you can just open this Java control panel, and if there is any settings which you want to do here, you can do it through your control panel also. Alright, let's close this. Let's minimize this window and this folder windows. So we have successfully done our step 1. So what's our step 2? We need to go ahead and install the Eclipse. Now same thing what I will do, I'll go to my browser, okay, and now I'll open another tab here and I'll say Eclipse download, and we'll go to this eclipse.org. Now here, whenever you're going to do this installation, you will see the latest version appears here. My recommendation to you is, if you're working first time, instead of working on the latest version available, I would suggest that you work with the last stable version. And that's exactly what we are going to do today. So for me to go to the previous versions, I just need to go here on this download packages, click on it. Okay, so once you click on that, on this page, if you scroll down, you will see something called as more downloads. Right? In this, you will see all the builds of Eclipse which is available, all your previous versions. So since today I'll be working with 4.10 version, I will go ahead and click on this 4.10. This 4.10 was released last year, this is 2018 December. Okay, and now when you look at this installer, you have multiple packages available here. So depending on your need, you can choose which package you want to work with. So today for our demo, what I would be using is Eclipse IDE for Java developers. So since we are going to be working on Mac, I will go ahead and click on this downloadable. And then I'll click on this download, which is going to download this particular file for me. I've already downloaded this file and kept it in my folder. Let's go to my folder. Okay, it's not opening. So let me click from here. And then let's go to our Selenium demo folder and in that installers. Okay, so now do you see this? Eclipse Java 2018-12 r blah 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 .dmg. So this is the file which we are going to be using to install Eclipse. Now as simple as what we did for JDK, I'm going to double click on this and install the Eclipse. So let's see how the Eclipse gets installed. Alright, so now I'll just move this folder into applications. Done. So my Eclipse is ready now. So simply let's go ahead and launch. So what I'll do, I'll just simply search for that on my system. Eclipse, there you go. And I'll just double click this. Is an application downloaded from the internet. Are you sure you want to open it? Yes, please go ahead and open it. Okay, it is launching it. So did you see how simple the Eclipse installation is? It's just downloading the package and just installing it on your Mac machine. Alright, when you start the Eclipse for the first time, you need to set your workspace. So workspace is place where you're going to keep all your folders, all your Java code or whatever you're going to do in Eclipse, all under that particular directory. So right now it gives me a default directory. Rather, what I will do is, since I have created a separate folder for our demos, I will go ahead and select that folder, which is my Simply demo. And then in this, I will add a folder called workspace. Okay. So that means in this particular location, whatever files I'm going to create, whatever code I'm going to write in Selenium is going to be stored at this location. And then I'll go ahead and say launch. So it will take a minute to load your workbench. Yeah, there it goes. So when you launch your Eclipse, right? So let me just make this window bigger. The first screen, what you're going to see is the welcome screen. Okay. Just go ahead and close the welcome screen. And this is the first view of your Eclipse, what you're going to get. So let's close out all the windows which we are not going to be working today. And I just need this main screen here. Now, what is the first step you're going to do once you have the Eclipse? I would go ahead and create a project first. So I'll simply say open file new Java project. Let's give a nice name to this since this is our first project which is going to be created. So I'll say Selenium first project. Now, if you observe here, so we have a JDK already installed and Eclipse needs a JDK to work with. And what it has done while I create my new project, it has already given me an option to use the execution JRE which you already have in the system. Okay? That's why it has already chosen Java 1.8. In case you have multiple Javas installed, in that case, what you can do is you can always go here, select this and select the Java of your choice. So say if you have got the latest Java, which is Java 12 installed on your system, it will give you an option here along with Java Software 8, it will give you Java 12 here. So you can go ahead and select that for this particular project. That option is also available. Now since we have only one JDK installed here, I will go ahead and create this project. So I'll just click on finish and it's going to create a project for me. So there are a few default things which it gets created. One is definitely the JRE system libraries, right? This is what we told Eclipse when we created project that my Java is 1.8. So what it has done is it has imported all those jar files which it requires for our Java programs to work in our Eclipse IDE. And then it creates a SRC, which is your source directory, wherein we'll be creating all our Java code or our Selenium test scripts. Okay, good so far. So this is a simple way of installing your Eclipse and getting your Eclipse ready to work with your Selenium. Alright, so now let's go back. So we have done the installation of Java, we have done the installation of Eclipse. Now what's left? Just the Selenium. Right. So what is that we need for Selenium? Let's go back to our browser. Okay. And this time we will go to seleniumhq.org. So this is going to be a Bible for you if you're going to be working with Selenium. So in this website, what I do is I go to downloads. And there are two things which we need to download for us to work with Selenium. One is the Selenium standalone server. Right? So when you're going to be working with remote Selenium WebDriver is when you would require this. However, I would suggest that we download whatever is required for us, even though we might not use it immediately. So what I just need to do is I need to click on this and it's going to download this server for me. Okay? So I have already downloaded it and I'll show you that. And then what we need is the Selenium client and WebDriver language bindings. Okay, we need a client. So what is the client which you are going to work in? We are going to working with Java client with the Selenium. And for that, I need to go ahead and download this. If you're working on say C# or Ruby or Python, then you have the respective packages which you can go and download. Now since we are going to be working with Java here, I would go ahead and click on this and this is going to download the Java client for me. Now as I said, since I've already downloaded it, so let's go ahead and look at what are those downloadables what we have. So let's close out this window. Now if you see here, one is the Selenium server standalone which we just downloaded. And then when you download the client libraries, what it does it creates a zip file. It downloads a zip file and it unzips it. And what is contained in that particular folder? So if you look here, Selenium Java 3. In this folder, you have multiple jar files, with which is what we'll be working with Selenium. Okay. So here you have 2 jar files here, and then under the folder libs, you have other jar files. Now these are the files which we will need. And now let's see how do we utilize this file in our Eclipse. So for that, let's go back to our Eclipse. Okay. So let me maximize this window. So in Eclipse, first thing what you need to do is click on your project. Okay. Right click on that. And then you have something called as build path. Go to the build path and say configure build path. Now here in this configure build path, what you need to do is go to your libraries. Okay. Go to add external jars. Now when you click on that, this is where you need to select all your jar files from what you have downloaded from the Selenium site. So that is present in our Selenium Java 3. So what I'll do, I'll simply select these 2 first. Okay. Then again you click on the external jar files. So what we have is in libs. So select all the jar files in the lib. Say open. Okay. You have all the jar files what we need identified here. Go ahead and click on apply and close. Once you do that, how do you know whether all those jars have been imported correctly? Go to the reference libraries. Here you should be able to see all the Selenium jars which we have downloaded to be listed out here. And so it lists here. So that means we have successfully imported Selenium. To test our installation, let's go ahead and write a small test script. So for that, I'll go to my source folder, right click, new, and we'll create a Java class. So let's name it Selenium first test. And I will also use a public static void main here. And I'll click on finish. Let's remove all these comments here which we do not need. So before even we write a first line of code, first what we need to do is create an object of WebDriver. So I'll say WebDriver driver. Okay. So now if you see this error, it asks us to import this particular WebDriver class from a package. And that package is org.openqa.selenium. Okay. So now you can see this import statement. Now let's go ahead and write our test case. Now for this test case, what we will do is we will simply launch a browser, say Firefox browser, and we will also launch a website. Now I'll create a method for that. I'll say public void launch browser. So if you have looked at our previous videos on Selenium WebDriver Basics, I have explained there that every browser which you want to work with in Selenium comes with its own driver. And this driver is what we need to download from the website of Selenium. And I'll show you how to do that. So if we go to that seleniumhq.org, under the downloads tab, if you go down, you will see something called as third-party drivers, bindings and plugins. So all the browsers supported by Selenium are listed here and their corresponding driver files are available. So now since we are going to be working with Firefox in this demo, I will go ahead and click on this latest release of Mozilla Gecko driver. So Gecko driver is the one which we'll be using for launching our Firefox. So just click on this and this will take you to the latest version of the Gecko driver available. So just scroll down and depending on the OS which you're working with, in our case it is a Mac OS. So just click on this file and download this file. Similarly, say if you are working with the Chrome driver, what you need to do is go to this Chrome driver, go to the latest, click on that and select the release which you want to work with and just download it. Now I've already downloaded this file and I'll just show you where they are. Alright, so in this directory, which is my installers directory, I have another directory created called as drivers. And what I do is usually I keep all my driver files under this folder. Okay, so I have a Chrome driver and Gecko driver already downloaded and kept here. Now let's go back to our code and see what is that we need to do to launch our browser. So there are 2 steps which we need to do for launching any browser which you want to work with. Right? First is you need to set a system property. So for that what I do is system.setProperty and this accepts a key and value pair. Now key for this is Gecko driver is what I need to provide here. And now that is in the quotes because it's a string argument. I say WebDriver dot Gecko dot driver. And the value is nothing but the path to your Gecko driver which you have just downloaded. Okay, let's go to my Finder. So that's here. So what I do is I simply right click on this file, get info, and I copy this complete path. Go to my Eclipse, paste this path here, and then the file name, which is Gecko driver. Done. So this sets a path to my Gecko driver. Now next step is actually launching the web browser. And how do I do that? I say driver equal to new Firefox driver. Now we need to do the same thing again. We need to import this class. So I say import Firefox driver. Alright. So now with these two steps, what we do is we simply launch the Firefox browser. And then let's go ahead and also launch a website, say Amazon.in. So for that I have a command called driver.get, which accepts a URL. Now this URL needs to be a fully formed URL. So for that, what I do first is I go to my any browser, I launch the Amazon.in website, okay, and then I copy this complete URL, go to my Eclipse and just paste it here. That's it. We are ready to launch the browser and launch Amazon.in. So let's quickly create a class here, or object here of this class. So Selenium first test, obj equal to new Selenium first test. Done. And then I need to call the method, which is launch browser. Okay, so now I save this file. I do a right click on this and I say run as Java application. Now this should launch our browser, okay, which it just did, and then it should take us to Amazon.in. Bingo. There goes our first script. So we have successfully executed our first script. So that means your Selenium is up and running.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of prime DevOps professionals. Click the link in the description box to unveil the wonders of this course.
You first understanding that what exactly is Gradle all about. Now Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily it's being used for the Java based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also, it's kind of standardized, because again if you want to automate something, standards or a standard process is something which we require for that before being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again other languages like Scala, Android, C++, Groovy, these are some of the languages for which we can use the same tool. Now it's actually using, like, it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now, again, it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also that okay, I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case this particular tool makes sense. Now Gradle includes both the pros of MAVEN and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and MAVEN, and again all the pros of Ant and MAVEN is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we are already having the tools like MAVEN and Ant which is available there, but primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of MAVEN also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and MAVEN, because again when we talk about MAVEN, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the MAVEN? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to MAVEN when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the MAVEN is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you're creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you're putting up in the MAVEN, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the MAVEN is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the MAVEN. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add it up into the case of Gradle, and we can override those tasks also. In case of MAVEN, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So MAVEN is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you are running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache, so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables, right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of a Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably, in which we have the executables and all, and then we have to have some particular environment variables configured, so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads, where this one is downloaded, we have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see that we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings. then environment variables. Now here we have to give it like Gradle underscore home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or an ER file. Also we can have, like in some tasks we can even publish our artifacts to the artifact tree, so that we can store those artifacts into a shared location. So there are different ways in which we can have this particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here. There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to MAVEN, because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it definitely provides a lot of support on how you can perform the builds, and it's being the latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental builds, so that can also be possible with the help of Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code, on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java it's something which is considered as in by default. Not even Java. In fact, Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with the Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have like how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory, so to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build.gradle. So in this one we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like Gradle tasks command over there. So Gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then Java dog, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run like Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here. And what is the status, whether it's a success or it's a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there. Right, let's go back to the main content. Right, now let's move on to the next one. So in the next one we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here, we are actually using the Eclipse for creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install, it will proceed with installation. It will download it. In some cases maybe it's part of the Eclipse as in the ID, so you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case we are installing it, and once the installation is done, we just have to restart the specific ones. We have to restart this Eclipse so that the changes can be reflected. So it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally and it is going to use the Gradle W or gradlew.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one the particular execution is done. Now we will be going for the project creation, so you can right click over here or you can go to the file also. So here we are going to go for the job project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle -project is something which is available there in this one. So that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one. Source, test, Java is the one which is available as in the folder structure, and source, test resources are also available here. So the main source, main resources are also available. Now in this case, what happens that these are the dependencies, project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as in within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to MAVEN repository where we will be opening a dependency link. So this is the dependency link here. So Selenium-Java is available, and it can give you the dependency for all the different options. Now we have for MAVEN, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do, like, for the first time maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. Right, so that's the way that how the particular executions or this Gradle project is being prepared in case of Eclipse, or the zip file gets downloaded. So you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one. Right now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see that we will give this path here. There is two environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle_home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle_version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation. As part of the installation of JUnit, you don't require to install any exe file or any kind of program there. There are a couple of jar files which is required, which needs to be there into the class path, so that every time when you write some JUnit test cases, you should be able to refer those jar files, because without having those jar files into your class path of your project, you will not be able to run the JUnit test cases. So that's the only dependency you require. If you are running a MAVEN build, then these dependencies will be added up into the pom.xml file. If you are referring or doing the build from the Eclipse or doing the development from the Eclipse, then you have to put up these jar files into the class path of the project, so that these jar files can be loaded up and the JUnit can be referred over here. So the installation is pretty straightforward, but let's see like what are the different steps we need to follow. Now, as a prerequisite of understanding the demo about JUnit, the first initial two things is like you require a JDK to be installed. Now you can download the JDK 8 over here from this Oracle website, and this is something which you can download for the Windows or whatever platform you have. You can pretty much install it for whatever platform is there. So for Windows platform, you can download for 32-bit and 64-bit both option over here. And once it's installed, so you should be able to use the Eclipse latest tool. Now all you need to do is that you need to go to eclipse.org, and there you can download the latest version of the Eclipse. Now these two main things which you require, because Eclipse will be required for creating the JUnit test cases, and of course a kind of IDE where you can run some test cases, JUnit test cases and all. And then Oracle is something which is required as a runtime for running the JDK also, and the JUnit test cases also, and Eclipse here. So that's a prerequisite which we got over here in this one. So I have already got these two things installed into my system, and I have Eclipse there. So let's move on to the Eclipse and see that how it goes on there. But before that, you also require the JUnit jar files, because in order to have a particular JUnit framework loaded up, we require some particular files, jar files over here in this case. So I can just search for JUnit 4 over here, and when you search for JUnit 4, so what happens, like this particular page will help you or give you all the details about the JUnit 4. Now you can go for the version notes of the different versions, but if you want to download, all you need to do is, like, you can say like download and install, and the moment you go there, so it will give you the details. Now there are 2 jar files which is required. JUnit.jar file is required over here. hamcrest-core.jar file, these 2 jar files are required here if you want to download it into the test class path. If you feel that you want to use a Maven based project, then in that case you have to specifically go for this dependency in the POM file, and according to that, that particular version will be downloaded and will be referred over there. So these are the ways that how you can get the particular softwares, the required things into the place. So I'm going to put up these jar files into a location so that I should be able to get the particular details stored, and I can refer to them into my Eclipse. So I'm going to download this one here from the Maven Central. So I'm going to download this jar file, and then I'm going to go back hamcrest-core, so that also I want to download. Download jar. So these 2 jar files I have downloaded, and I will be referring these ones into my project because these are the ones which is being required into my project as such. So let's go back to the Eclipse, and let's place these jar files into a location so that into my class path I can refer the complete folder with all these 2 jar files inside that. So let's go ahead with that. So let's create a particular new project over here. So we'll go for new Java project, and here I can give it like a simple one, a simple project name I can provide here, and JDK I'm using like 1.8, so that's the JDK version which I have utilized over here, and then finish. So this is the project which I have got like in the source directory. Now I'm going to create a simple file over here, a new class file over here. So I'll create it like JUnit class. So I'm going to create a class over here in this one, and of course I need to have a particular void main also over here in this specific class over here, because this is the initial class I'm trying to create over here in this one. I can create a custom particular methods also over here, but let's see like if we can execute or we can run some particular functions as such over here. Now I'm going to declare a function over here, public void JUnit method. So I'm just going to create a method over here. I'm just going to run a particular print statement over here. Executing JUnit test cases. Right now this is a kind of a method which is there, which of course I can run into my public void main, and this function will be executed, will be called upon over here. Now the thing is that right now since it's just a normal function, but the moment I convert it, like I have a @test mentioned over here, so what will happen, like this will be converted into the form of a test cases. Now of course, like right now there is no imports which is available there as part of this one, so you can see that the time I have added this annotation @test, I will be able to see like yes, add JUnit 4 library to the build path is something which is coming up over here, or it's saying like add JUnit 5. So whatever the library you feel that you want to add, you can do that, and that particular library will be added up over here. Now let's go for the JUnit 4 library here. The moment I do that, what will happen, you will see some changes. First you will see the changes in the top saying that import orj.junit.test. That's a first import, and second import will be like JUnit 4. You will see like these 2 jar files is automatically being picked up by the Eclipse. Now, even if you don't download these jar files, this is the main benefit of the Eclipse, that these are already a part of the plugins. You can see their paths, that these are already installed in the.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Plugins directory. So the moment you use these particular methods that you want to use the JUnit, these will be automatically imported over here into your system. Now you can just simply call this method into the main void main, and then the specific method will be executed as a form of test cases. So this is the mechanism that how you will be setting up the project. Initially you got the imports, you got the particular annotations configured, and with that the specific jar files will be automatically being added up into your class path. Whatever the jar files we added up, we downloaded previously, we can also have that added up into the custom class path. We can modify this build path of JUnit 4 which is coming up automatically. We can just simply say right click, build path, and configure. So this JUnit 4 we can actually import, we can remove it from our system, and we can add our external jar files also into the build path or the class path over here. So that depends upon you, that how you want to perform the customizations around that part. But yes, the particular main benefit of using the Eclipse is that it's already having the JUnit plugin installed. Both 4 and 5 version is installed. Whatever version you feel that you want to include, it will be included, and the plugins are already installed, so you don't even have to download the jar files manually. So that's how you will be able to do a very basic initial setup of JUnit, and how a basic project can be created over here in case of JUnit.
JMeter or Apache JMeter is an open source software which is a 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let's assume that someday your team lead tells you to perform performance testing of some website like google.com or facebook.com for around 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to the internet and accessing the same website? Now just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when a need for software like JMeter arises. So what JMeter actually does is that it simulates. It will simulate real user behaviors and perform load tests on a server, group of servers, network, or object. Moving further, let's have a look at the prerequisites to install JMeter. The only prerequisite of installing JMeter is that Java must be installed in your system. Since JMeter is an entirely based application, that's why having Java installed in your system is a must. Other than that, JMeter can be used in many operating systems such as Linux, Windows, Mac OS, or even Ubuntu. Now that we know the basics of JMeter, let's go on to installing JMeter onto our system. First, let's check if you have Java installed in your system. For checking that, we shall go to the command prompt and type java-version. We can see that Java is present in our system. Here, it will show the version of Java present in our system. The next step is to download JMeter. Go to Google Chrome and type JMeter download. Now go to the official Apache JMeter website and go to the binary sections. In the binary sections, we shall download the zip folder. Once the zip folder is downloaded, open the folder location, then extract the zip folder. Once the folder is again extracted, go inside the folder and go inside the bin folder here. The bin folder contains the JMeter script file for starting JMeter. Now it's time for us to launch JMeter. But before we launch JMeter, we need to know that there are typically two types of modes in which JMeter can be launched, the GUI mode and the non-GUI mode. The non-GUI mode may refer to two types, the first being running JMeter in the server mode, and the second refers to running JMeter in the command line. And if we talk about the GUI mode, then the GUI mode has a limitation which slows down the CPU utilization while running the recorded script. But GUI mode of JMeter is perfect for adding and editing new configuration elements, thread groups, and samplers, as a result of which you can view a number of different listeners helping for debugging. Here, today, we shall be using the GUI mode. So, to open the GUI mode, inside this bin folder, select the jmeter.bat file. Double-click on this file. This may take a while, and then the JMeter window will open up on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configuration of that element are added. As we see on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So, moving forward, let's rename this test plan. Let's name the test plan to be first JMeter. Now, when you click outside this window section, you can see the element name will change. Otherwise, you can just save this and also the name will change. Now, when this is done, the next step is to add thread groups. Right-click on first JMeter here and select the Add option. Then, in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. So let's name this thread group to be JMeter. It has several different options, like the action to be taken after there is an error. You can choose it in the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the users' hits. Third, there is also a loop count where you can choose how many times the test will run for the number of users. You can choose the test to run infinite number of times. There is also a scheduler here that will help you schedule the start time and the test's end time. For now, let's leave everything to be one only. The next step is to go to first JMeter and again to go to Add. In the box that appears, select Samplers. You can see all types of requests that JMeter can work on. For now, we will choose the simplest of them all. Let's choose the HTTP request. Here, you will have to give the address to some home pages or websites. So let's make it a little easy. Let's rename it to be Home Pages. Here in the server name or IP box, we have to give the server name or the IP. Let's pick a website. Let's go to the Simplilearn website. Copy the URL from here. Come back to the JMeter window and paste it in the server name box. Keep in mind we don't need to give HTTP or HTTPS since these are protocols which will come in the other box, and they will be automatically taken in the HTTP request case. Then in the path dialog box, since we have to access the route page, we will leave a / there. Now when our HTTP test is ready, we will perform the test on it. To determine what the result of the test will be, we need to add some more test elements. We shall again right-click on first JMeter, go to the listener options. Then in the box we can check the different type of reports that JMeter provides us. For now we shall select two of these. Let's choose View Results in Table and the View Results tree. Now save the test and run it. For running the test, there are three simple ways. First, you can simply click the green button here to run. Second, you can go to this Run option and choose Run the test. And the third way is you can right-click on first JMeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the results of the test. Since we had put the number of threads and loop to be 1, there's just one entry in both the results. Now let's try one more thing. We shall go to JMeter and change the number of threads and the loop count. Let's make the number of threads to be around 10 and also the loop count to be 10. And now run the test. After running the test, we shall see the results in the table and see the testing being performed. And the same happens in the case of View Results in tree. Since we have increased the number of users and the loop count, we can see the test being performed accordingly. Since the loop count now was 10, so for each user the test will run 10 times. And here on the screen we can see the time taken and the number of tests being performed and the status of each hit onto our website link.
Let's get started with what is performance testing. So, performance testing is one of the most important phases of any product launch, as it verifies and validates the overall product performance. This testing can be done in different forms depending upon the resource availability and the type and volume of the user base. The main agenda behind conducting performance testing on any product is to make sure that the product's performance is as expected before it gets launched into the market. So, performance testing is the process of testing a software application under a specific workload. Performance testing is a software testing process used to test the speed, response time, stability, reliability, scalability, and resource usage of a software application under a particular workload. The main purpose of performance testing is to identify and eliminate performance bottlenecks in the software application. Performance testing mainly focuses on three factors of a software program. First one is the speed. Here it identifies whether the response of the application is fast or not. Then comes scalability, where the maximum user load is determined, and the third one is stability, where the stability of the application is checked under various workloads. Now we know what is performance testing. Let us understand why we need performance testing. The only concern of a software system is not features and functionality. The response time, reliability, resource, and scalability are also important factors. So, the goal of performance testing is not to find bugs, but to eliminate performance glitches. Performance testing is performed to help the stakeholders with information about the application concerning the application's speed, stability, and scalability. Furthermore, performance testing reveals what needs to be improved before the product goes into the market. If there is no performance testing, the software might suffer from issues such as running slow while several users use it simultaneously, inconsistencies across different operating systems, and poor usability. Performance testing determines if the software or application meets speed, scalability, and stability requirements under expected workloads. Applications sent to market with poor performance metrics due to non-consistent or poor performance testing are likely to bring a bad reputation and fail to meet the expected sales goals. Now we know the relevance and need for performance testing. Let's look at the types of performance testing. So there are 6 types of performance testing. Namely, load testing, stress testing, volume testing, capacity testing, reliability testing, and scalability testing. Let's have a look at all the 6 types of testing one after the other. So the first type is load testing. Load testing is a type of performance testing where the application is tested for its performance on normal and peak usage. An application's performance is checked concerning its response to the user request and its availability to respond consistently within accepted endurance on different user loads. Here, the main consideration is the maximum load the application can hold before the application starts behaving abruptly. Then, another consideration is regarding how much data the database can handle before the system crashes. The second type of performance testing is stress testing. Stress testing is a type in which different ways to break the system are found, that is, how much load a system can sustain. Stress testing has an incremental approach where the load is increased gradually. The test is started with a load for which the application has already been tested. Then, more load is added slowly to stress the system. The point at which we start seeing servers not responding to the request is considered the breaking point. Here, the major considerations are the maximum load to a system can sustain before it breaks down. Then, how is the system broken down? And how will the system be able to recover once it has crashed? We also see in how many ways a system can break and which are the weak nodes that are to be kept in mind while handling the unexpected load. Moving forth, the next type is volume testing. Volume testing is the type where the performance of the system is checked with respect to the volume of the data. To execute a volume test, a huge volume of data is entered into the database. This test can be incremental or steady test. In the incremental test, the volume of the data is increased gradually. Generally, with the application usage, the database size grows, and it is necessary to test the application against a heavy database. If we consider an example, let's say there is a website of college having small amounts of data to store initially. But after 5 to 10 years, the data stored in the database of the website is much more and has become huge. Now comes the fourth type of performance testing, the capacity testing. So capacity testing is a type of testing where the application is checked for its capability to meet the business volumes. Capacity testing is generally done for future prospects. Here, the main concerns are if the application would be able to support the future load, if the environment is capable of standing the upcoming increased load, and what are the additional resources required to make the environment capable enough. Capacity testing helps in determining how many users or transactions of a given web application is capable of supporting and will perform well. During this testing, resources such as processor capacity, network bandwidth, memory usage, disk capacity, etc. are considered and altered to meet the goal. To consider an excellent example of capacity testing, we can see the case of online banking. Moving forward, the next type of testing is the reliability testing. Reliability testing is a type in which the application is verified if the application would be normal again after an abnormal state. It estimates the time that the system would take to return to its normal state to understand the concept. Let's say there is an online trading site that experiences some failure, and because of which the users are not able to buy or sell shares at a certain point of the day. But after a couple of hours, they were able to operate their shares and the application became normal. This is when it can be said that the application is reliable and can recover from its abnormal state. The last type of testing is scalability testing. Scalability testing is a type where the application is determined if it would be able to scale up whenever needed. The need for scaling up comes when there is an increase in user load. Now when we have learned the types of performance testing, we must learn the process of performance testing. So the process of performance testing is divided into 8 parts. That is, requirement gathering, selection of tools, performance test plan, performance test development, performance test modeling, execution of test result analysis, report. Now let's have a look at all of these processes one after the other. The first step in the process is requirement gathering. The requirements are identified and gathered from the clients by the performance team. This includes getting information on the application's architecture, technologies, database used, intended users, functionality, application usage, test requirement, hardware and software requirements, etc. The second step in the process is selection of tools. After the previous step, POC or proof of concept is done with the available tools. The proof of concept is a sort of demonstration of real-time activity, but in a limited sense. The list of available tools depends on the tool's cost, the protocol that the application is using, the technologies used to build the application, the number of users we were simulating for the test, etc. Now, the third step. The third step is the performance test plan. In reference to the above two steps, test planning and designing are conducted. The process of test planning involves information on how the performance test is going to take place, like the test environment, workload, hardware, etc. Moving forth, the fourth step is performance test development. In this step, the use cases for the identified functionalities are created. These use cases are shared with the client for their approval. Once the clients approve the use case, the script development begins. These scripts are validated against several different users and parallel to script creation. The performance team sets up the test environment. The performance team also takes care of metadata through scripts if the client does not take up that activity. So the next step is performance test modeling. Performance load model is created for the test execution. This step aims to validate whether the given performance metrics are achieved during the test or not. Then, the sixth step is execution of tests. The scenario is designed according to the load model in controller or performance center. Initially, the tests are not executed with maximum users that are in the load model. The test execution is done in incremental order. Let's say there are 1000 users. Then the scenario will begin testing from 100, then go to 250, then 350, and so on. It will gradually increase and go up to 1000 users. The next step is the 7th step in our process. That is the test result analysis. The test results are the most important deliverable for the performance tester. This is where we can prove the return on investment and productivity that a performance testing effort can provide. What makes the result analysis process more effective is that we must have a unique and meaningful name for every test result, which will help us understand the test purpose. In the test summary, certain things must be included, like the reason for failure, how the performance of the application changes regarding the previous runs. It is also a good practice to make a result summary after each test run so that the analysis results are not compiled every single time the results are referred. Then the final and the last step in performance testing process is the report. The test results should be simplified so that conclusion is clearer and should not create any derivation. The development team needs more information on analysis, comparison of results, and details of how the results were obtained. The test report is considered to be good if it's brief, descriptive, and to the point. Now that we know the performance testing, the next important topic to discuss is the understanding of performance testing metrics. The first is processor usage, which refers to the amount of time the processor spends executing the non-idle threads. Second metric is memory usage. Memory use is the amount of physical memory available to the processor on a computer system. The third metric is disk time, which is the amount of time the disk is busy in executing read or write request. The fourth metric is the bandwidth, that shows the bits per second used by a network interface. Moving forth, the next metric is the private bytes. It is the number of bytes a process has allocated that can be shared amongst the other processes. These are used to measure memory leaks and usage. Then comes the committed memory. This is the amount of virtual memory used. Then the next metric we have is the response time. It is the time between when the user enters a request to time to the first character of the response is received. Next metric is the throughput. It is the rate at which a computer or a network receives requests per second. Moving forth, the next metric is the hit ratios. The hit ratios are concerned with the number of SQL statements that are handled by cached data instead of expensive input-output operations. And the last metric in our list is the top waits. These are monitored to determine what wait times can be cut down to make the data retrieval faster from memory. Apart from this, some metrics like the rollback segment, garbage collection, thread counts, hits per second, CPU interruption per second, disk queue length, etc. Now, when we know almost everything that is needed regarding performance testing, it is very important to know the tools that make performance testing possible. Here are the top 5 performance testing tools in the market today. The first tool we have is the Load Runner or HP Load Runner. As the name suggests, the Load Runner is great when it comes to handling a large amount of users for testing. The second tool in our list is WebLoad. WebLoad is one of the best testing tools for stress and load testing. The next tool in our list is Load UI. Load UI is a great testing tool to map the scalability and speed of the target product. The fourth tool in our list is Neoload. It is one of the fastest testing tools with a speed of around 10 times the traditional testing tools that are integrated seamlessly into our existing software with a wide array of tests. The last tool in our list is the Apache JMeter. Apache JMeter is one of the best and most used testing tools in the market right now. It is highly capable of creating a large number of virtual users working on web server. Moving forth, we shall talk about JMeter and understand why JMeter is preferred over all the other performance testing tools in the market. So moving forth, let's see what JMeter is. JMeter or Apache JMeter is an open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. JMeter is originally designed for testing web applications but has since expanded to other test functions. To understand the concept of JMeter, let us assume that someday your team leads tell you to perform performance testing on some website like Facebook or Google.com for 100 users. What would be the first thing comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 10,000 users. This is when a need for software like JMeter arises. So what JMeter does is, it actually simulates. It will simulate the real user's behavior and perform load tests on server, group of servers, network, or object. Now, let's have a look at some reasons why JMeter is used for load testing. We have divided these reasons into 6 parts. The first one is it's free of cost. Second one is performance testing of applications. Next one, platform independent. The fourth one is customizable. Fifth is recording and playback. And finally, sixth is the community support. Let's see all of these one after the other. The first reason we have is free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, JMeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. Then the second reason is performance testing of applications. The application is used to perform performance testing on different types of applications like web applications, web services, LDAP, database, and shell scripts. JMeter can conduct load and performance tests for many different servers and server types: web, HTTP and HTTPS, database via JDBC, LDAP and JMS. The third reason is platform independence. JMeter is written and developed using Java to run on any environment or workstation that accepts Java Virtual Machine, for example Windows, Linux, Mac, etc. The next reason we have is that JMeter is customizable. Since JMeter is an open source application, it enables developers to customize whenever needed. JMeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand. Scripting is simpler and clearer, and adding and defining elements is more intuitive. Also, one screen shows everything you need: the script, the scenario, and the analysis. These samplers are highly customizable when determining which request to be sent to the host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop feature, making the application faster and easier. The next and the last reason on our list is incredible community support. JMeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on JMeter. Also, having an open source tool ensures that it keeps getting better and is always in line with users' needs and requirements. Finally, let's have a look into the demo that shows the working of JMeter. So the first step is we shall go to the Apache JMeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file. This might take a while, and then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, all the test plan elements are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, listeners, and everything will be stored here. I have renamed this test plan as performance testing. Now the first step is to add thread group. Right click on the performance testing, go to add, then go to thread or users and select thread group. Let's name this as perform. Here, the thread group refers to the used or created users or needed to run this test. It has several different options like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. Let's make the number of threads to be 2 and let's make the loop count to be 100. The next step is to add an HTTP request. For that, right click on the thread group, go to add option and go to the sampler option. In the menu that appears, select the HTTP request option. Here on the screen, there is a server name or IP box. we have to give the server name or the IP in that. Let's pick up a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the JMeter window and paste it onto the server name box. Keep in mind, we don't need to give the HTTP or HTTPS since these are protocols which will come in the other box, and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave the / there since we have to access the root page. And let's rename this HTTP request as simple. Now, to get results, we shall add listeners. Listeners are something that are used to provide the outputs of a load test. There are different types of listeners present in JMeter, and many may be added using plugins. We will use 3 different listeners here to have an idea about the representation that the JMeter provides. For that, right click on the thread group, then go to the add, select listener option and go to the view results in tree option. Then again, right click on the listener option and choose graph results. And for the third listener, again right click and select the view results in the table option. Now it's time to run the test. For running the test, there are 3 simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run the test. And the third way, you can right click on the first JMeter and choose to run. Let's simply choose the green button and run the test. First, we will have to save this JMeter test, and then we shall go on to check the results of the test. Here in the view results tree, we can see the test being run. The same in the case of graph results. We can see the throughput option, then we can also see the time the test has been executing. Since we had put the threads to 2 and the loop count to 100, so the test will run for a while. We can check the view results in the table. We can see different performance testing metrics on the screen. You can see the thread name, label, sample time per second, bytes, sort bytes, and the latency. And in the tree option, when we click on the test, we can see a lot of information appearing on the screen. These are again several performance testing metrics. And in the graph results, we can see the graph coming up on the screen now, which represents the test taking place with respect to the IP address, thread, and loop counts. So what JMeter exactly does is creates a request and sends it to the server. Once it receives the server's response, it collects them and visualizes those details in a chart or graph. After that, it processes the server's response, and finally it generates the test results in several formats such as text, XML, JSON, so that the tester can analyze the data. Let's get started with what is load testing. Load testing is a type of performance testing that determines an application's behavior when a large number of users access the application together. Here, performance testing is a software testing process used to test the speed, response time, stability, and reliability of the software application under a particular workload. The testing determines a system's performance according to real-life conditions. To give you a better idea, let's say you have a printer. So you want to test a printer by transferring large number of documents for printing, or test a mail server with thousands of concurrent users, or to test a word processor by making a change in a large volume of data. This helps to know whether the existing infrastructure is capable of running the application or not. Load testing checks how much load can a system handle. The testing identifies the limitations due to hardware like CPU maximization, network bottleneck, memory limitation, etc. And it also identifies the issues in software configuration such as web server, application server, database server, etc. It helps to identify the maximum operating capability of an application and checks the performance of the application under different load conditions of system components and database components. Load testing is conducted to determine the number of concurrent users that an application can support without performance deterioration. The response time of each transaction of an application and the network delay between the client request and server response are also checked. Load testing proves itself very significant when it comes to determining user demands and satisfaction. Several tools make load testing possible, such as Apache JMeter, WebLoad, LoadUI, LoadRunner, NeoLoad, LoadNinja, etc. Here in this session, we shall be using JMeter for load testing. So JMeter, or Apache JMeter is open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let us assume that someday your team leads tell you to perform performance testing for some websites like yahoo.com or google.com for 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with 100 computers and access the internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when we need a software like JMeter. So what JMeter does is it simulates. It will simulate real user behaviors and perform load testing on a server, group of servers, network, or object. Next, let's have a look at some reasons why JMeter is used for load testing. We have divided these reasons into 6 parts. It is free of cost, performance testing of applications, platform independent, customizable, recording and playback, and community support. Now, let's see all of these one after the other. The first one, free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, JMeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. The next one is performance testing of applications. The application is used to perform performance testing on different applications like web applications, web servers, LDAP, database, and shell scripts. JMeter can conduct load and performance tests for many different server types like web, HTTP and HTTPS, database via JDBC, LDAP, and JMS. The third important reason is its platform-independent nature. JMeter is written and developed using Java programming language to run on any environment or workstation that accepts a Java virtual machine, for example, Windows, Linux, Mac, etc. The next reason we have is JMeter is highly customizable. Since JMeter is an open source application, it enables developers to customize it whenever needed. JMeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand, scripting is simpler and cleaner, and adding and defining elements is more intuitive. Also, one screen shows you everything you need: the script, the scenario, and the analysis. The samplers are highly customizable when determining which request is to be sent to a host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop features, making the application faster and easier. The next and the last reason in our list is incredible community support. JMeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on JMeter. Also, having an open source tool ensures it keeps getting better and always in line with users' needs and requirements. Now, after we know about JMeter and the reasons to use JMeter, let's understand the process to perform load testing with a hands-on demo. The only thing that is kept in mind before this demo is we must have a fully functional JMeter on our system, and by now we know that JMeter can be used in any operating system like Linux, Windows, Mac OS, and Ubuntu. In this demo, we shall look into both graphical user and non-graphical user interface mode of load testing. So the first step is we shall go to the Apache JMeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file, this might take a while, and then the JMeter window will open on the screen. The home window is divided into 2 sections. On the left side, the elements of the test plan are added, and on the right side, all the configurations of the element that are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, the listeners, and everything will be stored here. So the first step is to add listeners. For that, go to test plan, right click on the test plan, Go to Add, then go to Threads, Users, and select a thread group. The test group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user's hits. Then the third one, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. For now, let's leave everything to be only 1. The next step is to add the HTTP request. For that, right click on the thread group and go to the option and go to the sampler option and go to the HTTP request option. Here on the screen, there is a server name or IP box. We have to give the server name or the IP in that. Let's pick a website and place the link in that box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from there. Now we have copied the Simplilearn's URL. Now let's come back to the JMeter window and paste it in the server name box. Keep in mind that we don't need to give up the HTTP or HTTPS, since these are protocols which will come in the other box and they will be automatically taken in the HTTP request case. So this is what I was talking about. Now let's rename this name as Simply. Moving forth, let's create one more HTTP request. For that, again, right click on the thread group, select samplers and select HTTP request and go to Simplilearn's website again. And there we have the resource link. Go to that link and copy the URL. Then place that URL in the server or IP address box. We shall remove the HTTP from that link and add from the end. Cut the resource part and paste it in the path box there. Here we will rename the HTTP request as resources. Moving forward, to increase a load a little bit more, we shall use one more HTTP. So this time we shall add one more HTTP request. Again, right click on the threads group, go to the samplers option and select the HTTP request option again. To add one more link to the server and IP address, go to Simplilearn's website, go to the corporate training link. Now copy the URL and go back to the JMeter window and paste that URL in the IP box. Now cut the corporate training part from the link and paste it to the other path box. We shall again rename this HTTP request box as corporate. Now let's save this file. In the save dialog box, let's name it as loadtesting.jmx. Now to get the results, we shall add listeners. Listeners are something that is used to provide the outputs of the load test. There are different types of listeners present in JMeter and many may be added using plugins. The listener we will use here is the tree, as it is comparatively easy to interpret. For that, right click on the thread group, then go to add, select listener option and go for the view results in tree option. Now it's time to run the test and check the load. For running the test, there are 3 simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run test. And the third is the way you can right click on first JMeter and then choose run. Let's simply choose the green button and run the test. After we run the test, we shall go to the check the results of the test in the view results in tree section. We can see the green symbol that states the test has successfully completed. Since we had left all the values to be 1 in the beginning, that's why there is just one test for each HTTP request. Now let's increase the load and let's change some numbers. Let's make the number of threads to be 10, ramp up the periods to be 2 and the loop count to be 10. Now let's run the test again with the green button. After running the test, we shall see the results in the tree and see the testing being performed. Since we have increased the number of users and ramped up the periods and the loop count, we can see the test being performed accordingly. Since the loop count now was 10 for each user, the test will run 10 times. So here on the screen we can see the time taken and the number of tests being performed on the status of each hit onto the website. This is how you perform load testing in graphical user mode. Now perform the same test in non-graphical user mode. We shall remove the listener, so let's remove the view results in tree. After this we will go to the command prompt. Then in the command prompt we shall put the bin folder path in the Apache JMeter folder. Let's go to the bin folder and copy the location from here. Now paste the path in the command prompt and execute it. Once that is done, the next step is to put the command prompt for JMeter load testing. This command has got three parts. The first part is the -n, -t and -l. Here the -n represents the non-graphical user interface mode. -t is used to specify the location of the test script. -l is used to specify the location of our output result. Now go to the location where our JMX file is stored. Let's search for the load testing.jmx file. Copy the path and paste it in the command prompt -t. In the link that we paste towards the end, make sure that you add the name of the file with .gmx. Now go back to the folder and make a .csv file, make an Excel spreadsheet and rename it with .csv extension. Now copy this path and go back to the command prompt and paste it after the -l. In the path, don't forget to add the name of the CSV file towards the end. Then execute the command and wait for the command to end. After the command is successfully run, you can see that the tree is successfully created, and towards the end of that execution, you can see that the message is the end of the run. Now you can go back to the folder and open the load testing.csv file. In that file, you can see the entire test result has been generated. This shows that the command has been successfully executed and the load testing is successful in the non-graphical mode without any errors. This is what we had in this demo. We saw the load testing in graphical user interface and non-graphical user interface mode. To have a better picture, we use dashboards. Dashboards include several graphs that explain the working of the website link we use in the HTTP request. The dashboard generator is a modular extension of JMeter. Its default behavior is to read and process samples from a CSV file to generate HTML files. It generates the report and at the end of the load test or on demand. The dashboard reports provide metrics like the APDEX or Application Performance Index. The dashboard also provides a statistics table, response time over time, response times percentiles over time, active threads over time, and response times in percentiles. We shall learn about dashboards and more in the forthcoming videos. In this video, we learned how critical is load testing in the software testing process and how it ensures high user satisfaction. A successful load testing will help to release high quality software.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with what an API is. We often come across this term while reading any technical blog or magazine. An API, or Application Programming Interface, is a programming code that enables data transmission between one software product and another. It is an intermediary software allowing two applications to communicate with each other. To understand API even better, let's take an example. For example, you're booking a flight. For that, you will begin with searching flights online concerning your destination, departure, return dates, and many more filters. To make all these choices, you interact with the airline's website and access their database and see if there are any seats available on those dates and what the costs might be. While you're doing all this, from the time to begin to the time you finish booking your tickets, you're doing that with the help of an API. To simplify it even more, it can be said that whenever we use an application on our mobile phone, the application connects to the internet and sends data to the server. The server then retrieves the data, interprets it, performs necessary actions, and sends it back to our phone. The application then interprets the data and presents the information we wanted in a readable way. This is what an API is. So that means each time we use an application like Facebook, send an instant image, check weather on our phone, or make some specific choices while online shopping, we use an API. Now when we have a good idea about what an API is, let's look at another major thing before going on to the hands-on demo. That is why we use JMeter for API testing. Apache JMeter is an open source software and it is used to simulate loads of various scenarios and output performance data in several ways, including CSV and XML files and graphs. We know that the Apache JMeter is 100% pure Java application, so it is available on every OS that supports Java 6 or later. Some of these specific reasons what makes JMeter a perfect fit for API testing are: JMeter enables fast API testing. It performs quick scope tests and enables load and stress testing. Then, as we know, it is an open source tool and supports load testing and stress testing. It has a lot of plugins and extensions. JMeter can be used across several platforms and can use various programming languages. Now, we know about API Basics and why we use JMeter for its testing. It is the right time to see the process of API testing in JMeter. To download JMeter, you can go to the Apache JMeter website and download the file. To know the entire downloading process and installing JMeter, you can check our JMeter download and installation video in our JMeter playlist. Moving on, I have my JMeter installed. I will go to the Apache JMeter folder, go into the bin folder and open the batch file. This might take a while and then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So moving forward, right click on the first JMeter here and select the Add option. Then in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error, or you can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run in finite times. There is also a scheduler here to help you schedule the time for starting the test and the time for ending the test. For now, let's leave everything to be one only. Now, for some sample APIs, go to your browser and search for some sample REST API for testing. In this, we will go to the first link, that is reqres.in, or request-response.in. We will create and run get, post, put, and delete REST API request in JMeter in the demo. Here in this link, we have all get, post, put, delete APIs. So we shall choose the first link here, list users. Here we have the link request. Open this link in the new tab. Then we have got the URL for this API. Copy this URL and go to the JMeter window. Then in the JMeter window, right-click Thread Group and go to Add. In the box that appears, select Samplers. You can see all types of requests that JMeter can work on. We shall choose the HTTP request. Here, you will have to give the address to some home pages or websites. Here, in the server name or IP box, we have to give the server name or the IP. So here, we shall paste the get API request URL. In the protocol box, we shall put the HTTPS. If in the URL the protocol would have been HTTP, then we would have left this box empty. In the URL, we shall put the URL link. Remember that we do not put any slashes here and that anything after the URL would be put in the path. So we shall remove the path from the URL and put it in the path box. Then we shall take part from the question mark and use it to give parameters. Since it is the GET API, we will have to give parameters. We will add the name in the parameters and give the name as page and value as 2. In this HTTP request drop-down, we can see all the different types of HTTP requests that JMeter accepts. For now, we shall leave it to be GET since we are using the GET API. And also, let's name this HTTP request as GET API. Now, when our HTTP request is ready, we shall perform the test on it. To determine what the results of the test will be, we need to add some more test elements. We shall again right-click on the thread group, go to the listener options, then in the box, we can check the different types of reports that JMeter provides us. For now, we shall select 2 of these. Let's choose View Results Tree and the View Results in the table. Now, save the test. I will save the test with the name API testing. And finally, let's run it. For running the test, there are 3 simple ways. First, you can simply click the green button on the run. Second, you can go to this run option and choose to run the test. And the third way is you can right click on the first JMeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the result of the test. Let's go to the View Results tree. Here, we can see the green status that shows the test was successful. And the view results in a table. We can see again the status is green. Since we had put the number of threads and loop to be 1, there is just 1 entry in both the results. Now, let's try one more thing. We shall go to the thread group and change the number of threads to be 10 and run the test again. After running the test, we shall see the results in the table and see the testing being performed. And same happens in the case of view results in table. Now in the view results tree, we can click on a request and see different information. Here, we can see the sample start, load time, latency error, etc. Same in the view results in table. You can see all such information in a tabular format. You can also see the response data here. This is the same data as it was there when we copied the URL from the browser. You can furthermore check the response headers and the request that was placed. Now, we are done with the GET API request. let's add the second request, that is the post request. Again, add a HTTP request by going to the sampler in the thread group. Then come back to the browser window and click on the Post API option. Then open the request URL in the new window. Then go to this window, copy the URL and come back to the JMeter window. First, let's rename this HTTP request as Post API. Then let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request drop-down, select the post option this time. Then let's go to the parameter part. Here, select the body data option, and we shall have to add body now. So go back to the browser window and copy the body from here. Come back to the JMeter window and paste the body here. Here you can check some advanced settings also in case you need them. For now, since this is just a demo, we shall keep it really simple. So let's run this. We shall go to our two listeners and clear the previous output. Then we shall save the test and run it. Now you can see the two tests are here. Since the thread count is 1, let's make the thread count to be 10 again. Let's see what happens. Now when I run the test, I can see the test running a required number of times, that is 20 times. Again, I can see information about different requests that include different parameters like latency, errors, etc. Now let's move on to our third API request, that is the put request. Go back to the browser and click on put request. Open the request in the new tab. Copy the URL and come back to the JMeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as put API. Then let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box. Address the server or IP address box and path in the path box. And in the HTTP request drop-down, select the put option this time. Here also we shall have to add body data. So go back to the browser window and copy the body from here. Coming back to JMeter window, select the body data option and we shall have to add body now and paste the body here. We shall go to our two listeners and clear the previous output, make the thread count to be 1 and then we shall save the test and run it. Now you can see the 3 tests here. Since the thread count is 1, here by clicking on the API request, we can check a lot of data like the response, body and response headers. And same in the case of view results in the table. You can see the data in a tabular format. Let's make the thread count to be 10 and again see what happens. Now when I run the test, I can see the test running a required number of times. And here I can see information about different requests. Now let us add our last API request, that is the delete request. Go back to the browser and click on the delete request. Open the request in the new tab, copy the URL and come back to the JMeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as delete API. Then, let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request dropdown, select the delete option this time. Here, there is nothing to be added in the parameters section. So, let's go to the two listeners and clear what all is there. Then save this test and run it. Since we did not make the number of threads 1 this time, we can see the test running n number of times. We can see the information of any API request by just clicking on it.
Let's get started with what is script recording. Record testing in JMeter helps testers to record and run their activity against test targets. It is a type of automated testing, but for multiple users, the test script is designed to record such scenarios. The proxy server allows JMeter to watch and record user activity while browsing web applications with a normal web browser. When we talk about proxy, it is a component that is present between you and the remote server. Let us say that you want to record web browser interactions when JMeter starts acting like a proxy. This is when JMeter script recording is used. Script recording is one of the advanced and impressive ways to figure out and eliminate the complexity of browser interactions in software testing. Now when we know what script recording is and how it is relevant, let's look into how to do it in JMeter. But before that, let's check the prerequisites of script recording in JMeter. There are three major prerequisites. First is having JMeter installed in your system. The second requirement is having Java installed in your system. The third and final requirement is having Mozilla Firefox in your system.
Now, let us have a look at the hands-on demo of how to perform script recording in JMeter. So, the first step is we shall go to the Apache JMeter folder. In that folder, we will go into bin folder and then select the jmeter.bat folder. Let us double click on that. This might take a while. And then the JMeter window will open on the screen. The home window is divided into two sections. On the left side, all the test plan elements are added. And on the right side, all the configurations of the elements are added. As we are on the test plan element, we can see the configurations of the same. Here, you can think of the test plan like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, all the listeners, and everything will be stored here. Now, the first step is to add thread group. So for that, right click on the thread group. Select add, and from add, go to threads or users, and in that, select thread group. Here, the thread group refers to the users. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then, there is this number of threads where you can choose the number of users you want. Then, there is a ramp up period in second option that states the time gap between the user hits. Third, there is a loop count where you can choose how many number of times the test will run for a number of users. You can also choose the test to run for infinite times. There is also a scheduler here to help you schedule the start time and the test's end time. The next step is to add an HTTP request. For that, right click on the thread group, go to the add option, and now go to the sampler option. Select the HTTP request option. Here, there is a server name or IP box. We have to give the server name or IP in that. Let us pick a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the JMeter window and paste it in the server name box. Keep in mind that we don't need to give HTTP or HTTPS since these are protocols that will come in the other box and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave a / there since we have to access the root page. Now the next step is to add the HTTP test script recorder. For that, right click on the test plan, then go to non-test elements and select the HTTP test script recorder option. The window on the screen shows several options. Here we can see the start option to begin the test. Then there is a box that has the port number. You can make this number whatever you like. I'll put this number as 1234 for now. Then let's go back to the Simplilearn's website and go to the resources page. Then come back to the JMeter's window and rename the recording controller as resources. Now let us add another recording controller so that JMeter works like a proxy with the help of HTTPS test script recorder. Then again go back to the resources page that we just opened and scroll down a little bit. Here we can see several technologies and several other links. In those links you can select any one of the links. I will select digital marketing here. Then go back to the JMeter window and rename the recording controller as digital marketing. Then finally, let's add a recording controller for the home page and rename it as Simplilearn's home page. So now we can see that we have a thread group here. Then there is a HTTP request where we have Simplilearn website in the server name. Then there are 3 recording controllers, one for the resources, the second for digital marketing, and a third one for home page. And last we have a HTTP test script recorder. Here, I will rearrange the recording controllers in sequence, putting the Simplilearn's homepage controller on the top and then placing the resources, finally digital marketing recording controller. Now, let us open Mozilla Firefox in our system. Go to the general option here and scroll down to the network settings. In the network settings option, select settings. In the window that appears, select the manual proxy configuration. Here, we shall put the port number. For now, I will put the port number as 1234 in this box. Here in the HTTP proxy, we have localhost and we have selected to use this proxy for FTP and HTTPS and then click on OK. Now go back to the Apache JMeter folder and now we shall use this Apache JMeter temporary root CA file, which is a security certificate file. So coming back to the Mozilla Firefox window, go to the Options tab and in this tab, I will type certificates and here we shall select view certificates. In the window that opens, let us import the security certificate from JMeter folder. Here we shall select these 2 boxes so that the proxy server can access the website that we shall enter here in the browser and then select OK. Coming back to the JMeter window, let us add some listeners to get the results. Listeners are something that are used to provide the outputs of a test. There are different types of listeners present in JMeter, and many may be added using plugins. For adding listeners, right-click on HTTP test script recorder. For adding listeners, right-click on the HTTP test script recorder. Then go to Add option and then go to Listeners option and then Add View Results tree. Now, let us add one more listener in the same way. We shall add View Results in tree. Now, in the HTTP test script recorder in the target controller option, save the target controller. Here in the drop-down, select the Simplilearn homepage option as we will begin the script recording for the homepage. Finally, let's start the test by clicking here. Click on OK. Now, go back to the Mozilla browser and here, let us open the Simplilearn's homepage. Now, come back to the JMeter window, go to the homepage recording controller. You can see the homepage controller has started. As you can see, the homepage controller has started recording the scripts that are being performed. These are the tasks that are performed on the client side to the server side. Now we can check both the listeners that we have put to see what all functions are working fine and what all are not. All the tasks from the time that we have entered to simplilearn.com in our browser are recorded in this homepage controller. To take the test further, go to the test script recorder and stop the test. Now here in the target controller, select the second controller, that is the resources controller. Now start the test again. Select OK. Go to Simplilearn's website, select resources. After opening the resources link, go back to the JMeter window. And now in the resources controller, you can see what all events are recorded from the client side to the server side. Once we click on the resources link, now again in the 2 listeners, you can check all the scripts and tests are successful or have failed. Now for our last recording controller, go back to the test script recorder and stop the test. Now here in the target controller, select the third option, that is the digital marketing. Now here in the target controller, select the third option, that is digital marketing. Start the test and select OK. Now get back to the Mozilla Firefox window, go to resources, go to digital marketing. After digital marketing link has opened, go back to the JMeter window. And now in the digital marketing controller, you can see what all events are recorded from the client side to the server side. Once we click on that link, I guess this is taking a while. You can see all steps coming under the recording controller, and then you can also see the two listeners. Some of the tests are being successful and some are not. We can sum this entire process as a way of communicating between the server and the client with a proxy server help. In this case, the proxy server is our JMeter. That is why it was able to record all the steps that are happening while we were performing any task. This is how we can perform the JMeter script testing in few simple steps. Now, when you are done with the proxy server, do not forget to go back to your browser and change your network settings back to normal. That is, go to these settings, select Use System Proxy Settings.
If you're ready to embark on a career path pulsating with excitement, innovation, and limitless growth, look no further than Simplilearn's GIT postgraduate program in DevOps. This comprehensive program equips you with the knowledge and skills to navigate the DevOps landscape with confidence. Explore the depths of continuous integration, delivery, and conquer the intricacies of automation and orchestration, fortify security like a digital fortress, and unleash the full potential of cloud technologies. Don't let this once-in-a-lifetime opportunity slip away. Ignite your career and join the ranks of triumph DevOps professionals. Click the link in the description box to unveil the wonders of this course.
Moving further, let's have a look at the prerequisites to install JMeter. The only prerequisite of installing JMeter is that Java must be installed in your system. Since JMeter is an entirely based application, that's why having Java installed in your system is a must. Other than that, JMeter can be used in many operating systems such as Linux, Windows, Mac OS, or even Ubuntu. Now that we know the basics of JMeter, let's go on to installing JMeter onto our system.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
First, let's check if you have Java installed in your system. For checking that, we shall go to the command prompt and type java-version. We can see that Java is present in our system. Here, it will show the version of Java present in our system. The next step is to download JMeter. Go to Google Chrome and type JMeter download. Now go to the official Apache JMeter website and go to the binary sections. In the binary sections, we shall download the zip folder. Once the zip folder is downloaded, open the folder location. Then extract the zip folder. Once the folder is again extracted, go inside the folder and go inside the bin folder here. The bin folder contains the JMeter script file for starting JMeter. Now it's time for us to launch JMeter. But before we launch JMeter, we need to know that there are typically two types of modes in which JMeter can be launched: the GUI mode and the non-GUI mode. The non-GUI mode may refer to two types, the first being running JMeter in the server mode, and the second refers to running JMeter in the command line. And if we talk about the GUI mode, then the GUI mode has a limitation which slows down the CPU utilization while running the recorded script. But GUI mode of JMeter is perfect for adding and editing new configuration elements, thread groups, and samplers, as a result of which you can view a number of different listeners helping for debugging. Here, today, we shall be using the GUI mode. So, to open the GUI mode, inside this bin folder, select the jmeter.bat file. Double-click on this file. This may take a while, and then the JMeter window will open up on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configuration of that element are added. As we see on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So, moving forward, let's rename this test plan. Let's name the test plan to be first JMeter. Now, when you click outside this window section, you can see the element name will change. Otherwise, you can just save this and also the name will change. Now, when this is done, the next step is to add thread groups. Right-click on first JMeter here and select the Add option. Then, in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. So let's name this thread group to be JMeter. It has several different options, like the action to be taken after there is an error. You can choose it in the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the users' hits. Third, there is also a loop count where you can choose how many times the test will run for the number of users. You can choose the test to run infinite number of times. There is also a scheduler here that will help you schedule the start time and the test's end time. For now, let's leave everything to be one only. The next step is to go to first JMeter and again to go to add. In the box that appears, select samplers. You can see all types of requests that JMeter can work on. For now, we will choose the simplest of them all. Let's choose the HTTP request. Here, you will have to give the address to some home pages or websites. So let's make it a little easy. Let's rename it to be home pages. Here in the server name or IP box, we have to give the server name or the IP. Let's pick a website. Let's go to the Simplilearn website. Copy the URL from here. Come back to the JMeter window and paste it in the server name box. Keep in mind we don't need to give HTTP or HTTPS since these are protocols which will come in the other box, and they will be automatically taken in the HTTP request case. Then in the path dialog box, since we have to access the route page, we will leave a / there. Now when our HTTP test is ready, we will perform the test on it. To determine what the result of the test will be, we need to add some more test elements. We shall again right click on first JMeter, go to the listener options. Then in the box we can check the different type of reports that JMeter provides us. For now we shall select two of these. Let's choose view results in table and the view results tree. Now save the test and run it. For running the test, there are three simple ways. First, you can simply click the green button here to run. Second, you can go to this run option and choose run the test. And the third way is you can right click on first JMeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the results of the test. Since we had put the number of threads and loop to be 1, there's just one entry in both the results. Now let's try one more thing. We shall go to JMeter and change the number of threads and the loop count. Let's make the number of threads to be around 10 and also the loop count to be 10. And now run the test. After running the test, we shall see the results in the table and see the testing being performed. And the same happens in the case of view results in tree. Since we have increased the number of users and the loop count, we can see the test being performed accordingly. Since the loop count now was 10, so for each user, the test will run 10 times. And here on the screen, we can see the time taken and the number of tests being performed and the status of each hit onto our website link.
Here we wrap up with Devops Tools. If you like this video, hit the like button, consider subscribing to our channel and hit the bell icon to never miss updates from Simplilearn. Till then, keep watching and keep.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.